Good evening, good evening, good evening, everybody. Dipali, Deepti, Rajendra Kumar. Okay, Rajendra Kumar is saying that he will not be able to join today's live. So, guys, good evening. Just give a confirmation in the comment section that whether I'm clearly audible and visible. And by the time, let me just set this comment screen, which I guess is very proper. So, yes, tell me. Am I completely audible and visible? Yes. So, yes. Hello, Deepti. Hello, Neeta Tiwari. Hello, beta. Good evening. Hi. I hope I'm completely visible and audible, guys. Chalo. Thank you. Thank you. Thank you. Let's start. Now, what is the target for today's class and what is the agenda for today's class? Yes. So we have got participants now. Harsha. Hello, beta. Then we have Techno. Hi, beta. Now, beta, what is the target for today? So, target for today is we will be starting the class 12th with a frame of mind that, sir, whatever NCERT, whatever this book, this Bible for JEE or NEET aspirants, because definitely, beta, as you have obviously observed that NTA is quite predictable. Yes, for NEET aspirants, they must be thinking, although what has happened is actually I mean, nothing bad if you compare with the re-NEET examination. But you think of a JEE aspirant, beta, we give the January attempt also, and we give the April attempt also. So we have a habit of having these n number of papers. But yes, obviously, one student will attempt one paper, but still in a year that one paper does every student get an opportunity to attempt two times. So for JEE per se, beta, the paper has to be very predictable, very based on NCERT, beta, because this is the book which government has issued. You can very well see that there are many remote places in India as well, and they also deserve an equal opportunity. So that's why this is a very, where somebody is doing good, we should appreciate also that they make this thing a point that they take NCERT as a reference so that it is approachable to all. But yes, if you ask me, sir, NCERT is such an important book, then why such references? Why PW? Why all of us release so many questions? Because beta, NCERT is not a good book to start. NCERT is not a good book to study. It is definitely a good book to segregate your advanced and mains level of syllabus, because whatever we teach inside our batches, it is relevant for JEE Advanced, and therefore in order to revise for JEE Mains, NCERT is a perfect book. But sir, we are class 12 students. Some of you must be having a feeling in your mind, sir, class 11th is wasted, yaar, what we'll do. Don't worry, because 5 chapters of organic and 3 chapters of physical and 2 chapters of inorganic is the whole soul work for class 12th chemistry. Out of those 5 chapters, beta, you will be blown if you are not taking help of class 11th organic. Obviously, the GOC and the general organic chemistry, those reaction mechanisms, you do not have to read it separately. Why, sir? Because beta, in your class 12th NCERT, every topic has to be revised and at the relevant time. So it will not be a burden for you, and we will be covering that GOC logic also whenever and whatever is required wherever. But we will be taking reference of this book, which is NCERT, but in order to in order to revise. So sir, but we have not studied. How you are planning to teach us the complete chemistry using NCERT? Beta, we will be referring only those topics of NCERT which are obviously there, and then we'll be making it bigger, as in the explanation and the questions that we'll be doing around it will be making us more relevant for JEE Mains. And obviously, if you, sir, but I want to attempt JEE Advance also, you can score very well marks in JEE Advance also. I have been to Xylem, the Kerala entity, the off Kerala offline entity of PW, and we have done the first class 12th JEE batch has passed from there, and the top AIR is around 700. I have spoken to that boy, and even that boy said, sir, I was just vigilant with A, NCERT, B, number of questions practiced around that NCERT, C, move one step forward, as in beta advanced, what they do is they mix chapters. They mix organic and couple up with with mole concept stoichiometry, so that now we have to do calculation also. But if you see your mathematics, then the JEE Mains paper of mathematics and JEE advanced paper of mathematics was not much different, and similarly they are doing in chemistry as well. Before 2003, JEE Mains Chemistry was far different. After 2003, 2004, 5, 6, they have tried to include all the conceptual side. So for mains also, you have to be very much confident with A, only content related to NCERT, and B, then you have to build up some concepts and logics and practice questions. So the more and more you practice, the more and more you grasp those logics. So I hope the path is clear, and we are starting with organic chemistry. What chapters are? Alkyl and aryl halides, the first chapter of organic chemistry. But as I already as I have already communicated that beta, this chapter will be a no-brainer. This chapter will be a weak asset for us if we are not confident with class 11th topic. So for hydrocarbons per se, I will be specifically picking alkanes and alkenes. Alkynes, you can very well, yes, it will be related later, but alkynes and aromatic compounds, which is benzene, those two areas of hydrocarbons we will skip. Although if you really want to do that also, then definitely I'll plan accordingly. But for today's session, where we intend to finish alkyl halides, first we'll be exploring alkanes, then alkenes, all the NCERT reactions, and apart from that, all the reaction mechanism which will be actually making alkyl halide very doable for us. But you have to promise me that you will be with me till the end. Second, take out your copy. Don't try to write and copy everything, but yes, try to attempt everything, try to learn everything with me, and post that. These lecture notes, this recording will always be there at the YouTube channel at PWJ English. But you can take help of these lecture notes also, which will be given to you. You just have to, after the live, just go to PWJ English WhatsApp channel and you can download these notes for free, and then you can definitely make your class notes. But for time being, I will not be doing any poll. I will be giving you answers, but you have to try to reach at the answer conceptually. So let us make this a very powerful and conceptual session. Sir, what's the duration and will you cover the reaction mechanism? Yes, beta. Yes, beta. I will be covering all the reaction mechanisms that are relevant to NCERT logic, because that will be relevant to JEE mains level. Yes, definitely you have to add some 10-12% that chat masala you have to add in the mains syllabus to enhance it and reproduce an advanced content. But yes, beta, one step at a time. So with this NCERT based JEE preparation, we will be largely focusing on the mains area. Okay, and then definitely once this is done, so we can always have a boost up classes. So those boost up classes will not be taking any efforts, because after that we just have to read few concepts along with many questions. So I hope the process is clear. Duration and you will cover. Yes, beta. Aman, I already said, duration, beta, it will be taking around 4 hours, maybe 5 hours. We will see. We will be chilling and we will be doing it. We'll be enjoying. We'll not be pushing anything. We'll be taking breaks so that it is there. It is coming in your head. The priority is not to read. The priority is to understand everything. Okay. Sir, is your JEE Mains one-shot lectures you took before enough for new starters from zero? Yes, Techno. The I guess in the Elevate JEE Crash Course series, which we have started just last year in the month of October, those lectures are already there in the video section of PWJ English. They are more than sufficient, beta. Chalo, perfect. So Neeta, Rajendra, hello sir. Why there is no Arjuna JEE class 11? Oh, Rajendra, I guess you are from Arjuna batch. Beta, there was some time issues, and yes, because of that, the Arjuna JEE class of chemistry was skipped for today. But yes, obviously we'll be covering because you have your test on 21st, and that syllabus is definitely well on time. And yes, the concentration terms also we have done, but with today's lecture we had to practice those interconversions, so that we'll definitely do in the next lecture. I regret uh, I regret that, Rajen, but yes, good to have you, beta. Chalo. So can I use this for Olympiad? Yes, Hamilton. But you have to couple it up with practice questions, relevant questions, because I will be giving you mains and advanced level of questions, more of mains, less of advanced, because target is NCERT. And beta, don't say this more of mains, less of advanced, because advanced paper also, if you try to, let's say, achieve an AIR of around 1000, 2000, not below 1000, then beta 50 to 55, I mean, yes, sometimes 60% of the paper is easy and moderate only. 60% of the paper you can make without doing one extra thing. Just stick to NCERT and advance. 50 to 60% paper is done. Yes. But it may maximum land you to an AIR of 1000, maybe 800. But above that, you have to make one question correct, two question correct. So that obviously requires a bit of more inputs. But beta, mains is equal to 1000 in AIR, 1000 in JEE Advanced as well. In order to get AIR 1, people don't even realize this, that beta first become AIR 1000 and then try to cover the difference of 1 and 1000. Yes, definitely that will require efforts, but those efforts has to be channelized properly. You cannot uncover a puzzle if you don't proceed step by step. So this is the step by step process that we are intending to start with you. Chalo. This lecture or Elevate Vancha is more detailed. Should I refer both? Beta, you should refer this first and then go over there. Although, beta, we are teaching the same chapter, so I cannot go beyond NCERTs. Obviously, I'll be iterating that NCERT also. But yes, the iteration once done live gives a one-to-one connect between student and teacher. And yes, sometimes in a recorded session, you don't feel that much of enthusiasm which you feel in a live session. Oh, use something at chemistry calculations. Calculations, beta, 2 into 2 is 4 in chemistry also, physics also, maths also. So you are having problem with Divyanshu, then calculation, Divyansh Gupta. So you dash at chemistry calculations. That means you dash at calculations. So start practicing calculations rather. So please reply. Yes, Ashmit, what you are asking? Ashmit Anand. So please reply. I can't see your question, Ashmit. Can you frame that again for me? Sir, yeah, we have Mr. Hamilton with us, and aspiring for AIR1 beta. The first step to get AIR1 is to have this proper positive energy, which you definitely have. You have this and you have communicated the same. Now let me answer Ashmit. Sir, in organic chemistry, I'm not able to process at what time, which reagent to be used for conversion, what to do, sir. Beta, that means you know trigonometry. Trigonometry questions, Ashmit, you must have solved. Once you have to reach from LHS to RHS, you have to use some set of properties. Those set of properties you may have proved, but you remember them in your mind. How you remember them in your mind? By practicing the same property at least 5 to 6 questions. 5 to 6 is the minimum. At least 5, 6, maybe more questions you have practiced on the same property, but you don't do it in chemistry. Those reagent you have to learn how, by practicing more and more questions. The moment you practice more and more questions, the moment they will be in sync with you. So this is just a idea, beta. We write maths again and again using the same formula, applying in at least 5, 6 questions, and we feel we are not learning. Beta, actually you are learning the process. That is not bad, but at least have an idea that you are writing and learning. Remember class nursery, how you learned how to write? You teacher must have written CAT in your copy, and you should write CAT 10 times. The same thing you do in maths. One question solved, then you try to solve at least 5, 6 questions of the same pattern, so that you learn the process. So you write and learn the process, you practice. So in chemistry, if you are not practicing much, then at least go to your notes again and again, so that those reagents get inside your head, get inside your system, get inside your subconscious. है ना? I'm Ashmita, sir. You just changed. Okay, I'm sorry, yaar, Ashmita. Please, yaar. I read Ashmit Anand. Okay, Ashmita Anand. I'm sorry, Ashmita. I'm sorry, Ashmita. Chalo. Sir, I have problem in GOC, unable to solve questions. Beta, everything Raj, question Raj name. So everything Poonam or maybe Raj. Poonam Singh is the name written, but you are saying question Raj name. So maybe Raj is your name, beta. Whatever GOC problems you'll be having, I will be covering everything once I will be starting this chapter. So let us begin, beta. Shall we start the class? Come on. I'm able to remind the name of the reaction. So if you ask me Swarts or Finkelstein or something, I can write and explain, but during conversions, okay, beta. Then Ashmita, you just need practice, beta. That's it. Hello, Chetan. I'm good. Thanks for asking. I hope you're great too. Chalo, beta. Let's start. So from where we have to start, sir? Beta, we are starting the session with alkanes. And how alkanes? Let us quickly jump to our Bible first. Where is my Bible? Here it is. Hydrocarbons. Now just try and understand this, beta, that whenever you are going through NCERT, how NCERT has divided whole of the chapters. So first they deal they give something about the history. So hydrocarbon they are whatever the fossil fuels we have, whatever diesel, petrol we have, whatever LPG gases we have, whatever CNG gases we have. We do combustion of those hydrocarbons, those alkanes, and we produce energy. That means they have very good calorific value. What is that calorific value? The amount of heat evolved per gram of those substances. You are a lifesaver, sir. This is the exact lecture I want. Okay, techno, perfect. Beta, I mean, I have been teaching since 2012. So practically, I know what people want. I know what students want. So chill, है ना? Chalo, let's start. So how does NCERT give you the picture? So first they give you some basic, then starting with alkane. Now first alkane, you have to know the nomenclature and isomerism. So sir, you have to educate us regarding the nomenclature and the isomerisms shown by hydrocarbons. Point number 1. Then sir, they after solving some questions around it also, yes, number of questions in NCERT is very limited, but beta, they give you the probable type of questions. So we'll be discussing all these, I mean, with our slides obviously, and post discussion of IUPAC and isomerism, the next topic for every organic compound as per NCERT is, then you should know the number of preparations. Like Ashmita was saying, she forget how to use the reagent. So because you do not have those number of preparations and reactions in your tip. So how many preparations you have? First is from unsaturated hydrocarbon. So finger 1 is from unsaturated hydrocarbon. Then you should know details about it. But first you should know what is the number of preparations. So first is from unsaturated hydrocarbon. Second is from alkyl halides. Yes, there will be n number of methods, but second is alkyl halides. Third is from carboxylic acid. That's it. So NCERT in alkanes tells you there are basically 3 methods of preparation: from unsaturated hydrocarbons, from alkyl halides, and from carboxylic acids. So these are the 3 preparations. After that, you should know the physical properties. After that, we'll be dealing about the physical properties, and then regarding the chemical properties. Now, how many chemical properties NCERT have for alkanes? First one is substitution reaction, basically halogenation. Halogen comes and substitute hydrogen. Second is okay, for halogenation they have detail also in at least 30. The second page also is covered, around 75% of the page they are discussing about halogenation only. So that means halogenation is important. You should know everything around it. Then comes is combustion. Now after combustion you have controlled combustion, because combustion is nothing but reaction with oxygen. So after that you have controlled oxidations. Then you have isomerization, number 4, aromatization, number 5, reaction with steam, a very small reaction, inorganic reaction, reaction number 6, and last is pyrolysis, which actually helps us to understand how this petroleum industry works. So ultimately, how many reactions we have? So 7. Iterate them so that you should learn them. What are these 7 reactions, sir? So the first reaction is substitution. Second reaction is combustion. Third reaction is controlled combustion, or rather controlled oxidation. Next, sir, you have isomerization. I can isomerize those compounds. Next, sir, after that you have aromatization, and last two are, sir, reaction with steam, and sir, last one is pyrolysis. So these 7 reactions you should learn what is the sequence and then know details around it. So let us fill these alkanes with details. So starting with obviously what the general properties with which NCERT start, we are mixing it with physical properties. So what are the physical properties of alkanes? So let us list them and try to learn them step by step. So the first one is beta. Obviously, if you have your alkanes, then these alkanes are called paraffins. They are nothing but saturated hydrocarbons with general formula CnH2n plus 2. A very easy point, sir. Now, many students feel discomfort because, sir, they do not remember this degree of unsaturation. Because in order to predict the structure, you need some degree of unsaturation units. Why, sir? Because we will see in questions, without knowing the degree of unsaturation, you cannot predict. But I suggest to my students, beta, don't learn, because obviously we have lot of stuff to learn. So minimize those stuff with common sense. What is formula of an alkane, sir? CnH2n plus 2. Just remember this, and if I have 2 hydrogen less than required for saturation, I will say du is 1. If I have 4 hydrogens less, I will say du is 2. So 2 hydrogens create degree of unsaturation, which is sometimes some references call it double bond unsaturation. So whatever it is, whatever is the degree of unsaturation, it is because of in formula 2 hydrogens are less. So if you have 2 hydrogens less, that means unsaturation level is 1. Just remember this, and you do not have to learn any formula. Clear now? So the first is telling us the molecular formula of alkanes, and alkanes are called paraffins. Now why paraffins? Because in Latin para means little and affins mean affinity. So because they have very little affinity. Now why do they have very little affinity? Because, sir, in alkanes there is practically no polarity, sir. If you have carbon-carbon chain, sir, then obviously, sir, there is no polarity. Point number 1. Sir, the electronegativity difference between carbon and hydrogen also is very less. And because it is very less, so practically this bond is also not polar. If there is no polarity, how come I can react with any reagent? Because reagent attack, what is basically reaction mechanism? Sir, who moves? Electron moves. So what is positivity for us? So positivity is deficiency of electron. What is minus? Sir, excess of electron. So excess of electron will always move towards there is deficiency of electrons. So this plus minus attraction is nothing but our reaction mechanism, which we definitely have to focus. Cool. Chalo, let me read some of those comments. By the time most of you, if you want, you can write also. Let me read those comments first. Is this sufficient for JEE mains if I solve P? Yes, beta. Shreya Mishra. Obviously it is more than sufficient, Shreya. Sir, I'm not able to understand 12th chemistry cause I didn't study 11th. That's why, beta, I'm starting 12th with 11th topic, because in that ways it will be helping you like piece of cake. Okay, Neha, hello, beta. Okay, Neha as in superstar. Superstar is here. Superstar is excellent, neat performer also, and she is a JEE aspirant also. Yes, Dipti, perfect. It will. Chalo. So these all are the comments. So let me start. I mean, let me continue. I've already started. Chalo. Sir, next point, sir. Okay. So next point is, beta, the physical state at room temperature. Now, alkanes having carbon 1 to 4 are colorless and odorless gases. 5 to 17 are colorless, odorless, but they are in liquid state. Except what? Sir, except neopentane, which is a gas. What is, sir? These are general naming. So let us start these naming also. What is neo group? It is a general name. What does neo stand for? Sir, tertiary carbon. What is a tertiary carbon? A carbon which is directly connected to 3 carbons is a tertiary carbon. So what is a neo group? Sir, it is a structural general naming. As in, what is structural general naming? Neo, when you say a group is neo, when you have a tertiary group, point number one, the group, the carbon next to a tertiary carbon. So the carbon, this is a tertiary carbon, and the carbon next to a tertiary carbon, this white colored carbon is called the neo group. Now, how many carbons you have required to make this complete neo group? Sir, 1, 2, 3, 4, 5. Don't count main chain, the total number of carbons, because it's a general name. Sir, 5 carbons. Then this becomes a neopentane. Let's say if I add halogen in this carbon, it will be neopentyl halide. If I add alcohol over here, if I add OH over here, sir, it will be neopentyl alcohol. Sir, how about if you need neohexyl? Then beta, this picture I need. I cannot change this picture because I hope you remember what is neo group. Repeat after me. Carbon next to a tertiary carbon forms a neo group. Again, carbon next to a tertiary carbon forms a neo group. I hope the definition is clear to you. So, sir, this is neopentane. So, if I need to form neohexane, so beta add one more carbon. Sir, where? You can obviously add here because that carbon defines your definition. So, if I add one more carbon here, sir, it is still carbon, the white carbon is still carbon next to a tertiary carbon. But how many carbons are utilized to make this picture? So 1, 2, 3, 4, 5, 6. So this will be neohexane, so on and so forth. These are the general naming that you should know. Perfect. Perfect. कुछ मिस नहीं हुआ नेहा तुम्हारा? Yes, नेहा, nothing has been missed. कल नहीं आई. Okay, now people are doing peer-to-peer doubt solving. So let's start. Chalo. So I hope this is also clear to everyone. This is nothing but neohexane now. So sir, if you have only 4 carbon atoms, sir, you have already told us carbon and carbon chain is not polar. So what attraction force they will have, sir? Weak van der Waals forces. What are weak van der Waals forces? Beta, non-polar molecules are still made of nucleus and revolving electrons. Revolving electrons will revolve. So if they are here, then they are not here. So this creates a partial delta minus and delta plus, but this is partial charge and instantaneous charge. Similarly, another molecule will also have this partial and instantaneous charge. The attraction between these instantaneous dipole-dipole is called London dispersion force, which is a very weak van der Waals force, which is responsible for the attraction between different alkane molecules. Now, as the carbon chain increases, beta, the attraction force will increase because the molecule is getting larger and larger. And that's why as carbon chain is increasing, intermolecular attraction is increasing. As intermolecular attraction is increasing, their probability of coming into liquid state or solid state will increase as carbon chain will increase. So this is a common sense. Now let us relate with the NCERT fact. 1 to 4 carbon chains are very less attraction, so they are gases at room temperature. Another property is they are colorless and odorless. That is a factual NCERT science, so you have to learn. Sir, from 5 to 17, because carbon chain has increased, so 5 to 17 members have such level of attraction that their physical state becomes liquid because attraction force must have increased. But sir, till what carbon? Till 17. After 17 carbon, that is from 18 and above, the attraction force, although weak, but because the carbon chain has increased substantially, so attraction force also has increased substantially, although weak. After 18 members at room temperature, they exist as solid. But what solid? Sir, wax type of solid. You definitely have seen those wax, the candles. So they are also hydrocarbon, but having very high carbon chain. Moving forward. Cool. Chalo, perfect. So next, sir, alkanes being non-polar molecules, sir, obviously you have told us, sir, they are soluble in polar solvent because like dissolves like, so non-polar molecule will be dissolved in non-polar solvent. That's why the oil, whenever you get that oil or dirt in your skin, if you just wash your face by splashing water, that oil is not removed because water is a polar solvent. Oil rather is non-polar, so that attraction does not happen. So what you do, you apply some face wash or soap, which creates a missile action, and because of the formation of that missile, now that foam removes oil from your face. So that's why you need a face wash if your skin is very oily, because oil, organic, will not be soluble in water, polar. I hope it is clear to everybody. But sir, it will be soluble in non-polar solvent. What are these famous non-polar solvents? Are organic compound, yeah, come on, like benzene, ether, chloroform, and obviously they are insoluble in polar solvents like water. So this is simple, sir. Now their solubility decrease with increase in molecular weight. So as you increase the mass, their solubility will definitely decrease. I hope everybody is clear. Sir, the amount of English you're gonna speak is less than the amount of English my whole class spoke in their 70s. So, may goat, I take that as a compliment, but beta, have that level of compassion. Again, I'm telling you, last week I have been to Kerala, Xylem. Beta, the students, I mean, awesome students. And you know what is the level of communication? What is the medium of communication for them? Either Malayalam or English. So we feel that Hindi is a very, yes, definitely Hindi is our mother tongue. Hindi is the national language. But beta, there are many students not comfortable in Hindi rather. And this is the initiative, this is the effort which obviously our boss Alak sir has done. And this is for because those students were having no practical uh, background rule or background or resources, and now these English platforms has definitely given them those resources. So obviously if you are in a northern side of India, then you will feel, sir, yaar, come on yaar, this much of Angrezi, you know Angrezi, sir. But practically it helps a lot, beta. So have that level of compassion. But I know, goat, may goat, I know you have just been sarcastic. So yes, pun intended and pun taken. Chalo, moving forward. Now, let's move forward, sir. Now, coming to some basic points which I've already, boiling point and melting point. So obviously you have said, so that means, sir, if I have a 3 carbon chain, or rather if I have a 6 carbon chain, or rather 5 carbon chain, you tell me who will have more boiling points, sir, as intermolecular force as carbon chain increase, or obviously some melting point and boiling point of the alkane with more number of carbon atom will be high. So easy question, but yes, definitely you should know this. Now, for isomeric alkane, sir, for isomeric alkane, number of carbon atom is same because isomers have same molecular formula. Isomers have same molecular formula. I'm working on English too. Huh? Good. Perfect. Chalo, chalo. Now, isomers have same molecular formula but different structural formula. So, sir, carbon chain will be same. So, for them, boiling point is inversely proportional to branching. This is the key. This is the key point that you have to keep in your mind always. It will help you like anything. What? For isomeric alkanes, boiling point is inversely proportional to branching. Sir, give us an example. Like I have normal pentane, sir, 5 carbons, pentane. This is isopentane general name. So educating you, making you learn this general names also. What is iso group? It is also a picture like neo group. First carbon, second carbon, a methyl branch with a free valency. Now this yellow thing where I have circled also is the picture of iso group. Like what is neo group? So tertiary carbon and the carbon next to tertiary carbon. That means that it is also made of 5 carbons. So that means neopentane is also an isomer of pentane because both of them have same molecular formula. And this isopentane is also why? Because what is iso? It's a general name, first carbon, second carbon and a methyl branch, then free valency. So this constitutes your isopropyl group. If I'm adding 2 more carbons, so this will be isopentane, 6 isohexane. If I will not add ethyl group and rather I introduce a halogen, this will be isopropyl. If I add isopropyl halide, if I add OH, sir, it will be isopropyl alcohol. So if I have added alkane, so this will be simply isopentane. I hope it is clear to everybody. I hope it is clear to everybody. Now, in them, sir, they have same molecular formula, they have same mass, but who will have more boiling point? Sir, this guy will be having more surface area, sir. So one pentane and another pentane can attract each other with more number of lines of force of attraction because surface area of the molecule is more. And as the molecule is becoming compact, so surface area is decreasing, sir. So attraction line of forces will also be decreasing because molecule surface area is decreasing as compactness is increasing. How compactness will increase? Once branching will increase. That's why I'm saying if branching is increasing, surface area will decrease, and because surface area will decrease, therefore boiling point will also decrease. That means boiling point is inversely proportional to branching, which clearly tells us that pentane will have highest boiling point, then isopentane because it is less branched, and the highly branched compound is neopentane, which will be having least boiling point. Mind you, this is regarding boiling point. Now coming to melting point. So for melting point, the first thing that you should know, but sir, boiling point, melting point, both depends on intermolecular forces of attraction. Agreed. But beta, you melt whom? Sir, we melt a solid. You boil whom? Sir, I boil the same compound but in liquid state. So once you have a compound in liquid state, or rather once you have a compound in solid state, one more factor come into effect, which is symmetry. Once you have I mean, just with this common example you can understand this. If you pack your suitcase with clothes on them, in what case you can fill your suitcase with optimum number of clothes? Once you pack your suitcase with proper arranged jeans shirt pattern, or you randomly just crush your jeans and pant and put inside your suitcase? Sir, once you have properly segregated your jeans pant, the stacking will give best packing efficiency. So that's why if we are going to pack us any solid, nature also calls for the same symmetry. Nature rather proves us with the value of their melting point that whoever structure is more symmetric. Now you tell me who is more symmetric. Sir, this is a perfect ball, sir. This is not symmetric, sir. That is a perfect ball. So once you talk of melting point, you will mysteriously see that neopentane or any compound which is more symmetric will rather have more melting point. And this is also seen with a phenomena very less told by teachers, which is known as alternation effect, which clearly says alkanes with even carbon have higher melting point. Sir, then this will be contradicted, sir, because you said as carbon chain will increase, intermolecular attraction will increase. If intermolecular attraction is increasing, melting point and boiling point both will increase. Definitely this is good for melting point, this is good for boiling point also, but you should keep this thing in mind that carbon with hydrocarbons or alkanes, precisely because we are particularly talking of alkanes in this chapter. Alkanes with even number of carbon atom has more melting point. Let me give you an example that this is also followed and this is also followed. See, look at the pattern of the values. N-propane or N-butane. N-propane has a melting point of 85 rupees, for example. Obviously this is the exact data in Kelvin, and N-butane has a melting point of this. These are melting point. I'm not asking you to learn, just try to understand this point. So 85 and rather 140. So increase of around 55 rupees. Okay. Sir, N-pentane and N-hexane. See, melting point is increasing. So as carbon chain is increasing, melting point and boiling point both are increasing. But look at the change. Propane is 85. This is approximately 55 rupees, approximately 50-60 rupees change. Now, butane to pentane. See, melting point is still increasing. From 138, it is coming 143. Sir, but 5-6 rupees increment, because this is pentane as an odd number of carbon. So pentane to hexane, see, again, increment is again 30, 40, 50 rupees. Because, let's say 140, so 180. So again 40 rupees. Here increment was 4-5 rupees. From odd to even, increment is 10 times more. Again, sir, this is even number, that is odd number. So this is 179, this is 182 to 186. I mean, see, again increment is just 5-6 rupees. Is this rule contradicted? No, sir. Melting point and boiling point both increasing, sir. See, increasing, sir. But you should understand with the change that, sir, for even increases more, for odd increases less. Hello? Chalo. Now let me see some doubts. Sir, my chemical bonding, by the time I want everybody to just, if you're making notes, please write them. Sir, my bonding and GOC is not strong. So can I understand 12 beta? Oh, my dear friend, Dome, beta, that's why I have started organic with 11th only. Sir, it will increase my efforts, but no worries. If I am able to help even one, my job is done. I am very, very happy. I am super happy. Come on now, guys, write it down. That will also give me a time to breathe. Okay, I already had coffee, but it has become cold coffee. Chalo, write it down, or else maybe I have question after this or what? Why write it down? Attempt the question. Sir, there is no poll. I've already given you answer. Bombay, but I want you to have a justification around it. So build a justification around it. Yes, Lewis is asking some question. So let me just sit and answer your queries, because this is what live session is all about. Teacher student connect. The branching, Hamilton is asking, sir, branching decreases boiling point of an alkane. As branching will increase, boiling point will decrease. Yes, because the molecule becomes spherical, reducing surface area and van der Waals forces. Yes, Hamilton. Perfectly framed data. But if it becomes a compact sphere, shouldn't it pack tighter and make the substance denser? Why does density sometimes decrease or stay nearly flat with branching? Beta, see, you can have few examples to contradict that, but in general, beta, in general, because see, we have formulated these theories because we have got factual content confirming the same. But if you talk of density beta for alkanes, or basically for every, basically obviously because this is mother nature, so obviously you can have some contradictions, but in general beta, density largely depends upon mass. As carbon chain will increase, mass will increase, and so does the density. So for density, generally we don't see such exceptions, right? That's why generally we do not give any conclusion also regarding it. I hope it is clear, Hamilton. Chalo, perfect. Now let us move forward. Now, sir, obviously, sir, you have given answer also, because beta, with this lecture I do not intend to check you. What I will check first, I will teach you, then I'll ask questions. But yes, this is organic, and because we are focusing NCERT based content, so I am asking you, I'm giving you answers and trying, and I'm asking you to come to a conclusion, a logical conclusion, that why it is an answer. Come on, now let's read. Neopentane forms only one monosubstituted derivative. Now, I guess this you know from class 10th, that's why I'm using this. What is substitution? You remove one hydrogen and substitute anything. The basic substitution reaction is halogenation. Okay, sir. So what is neopentane? Sir, you have already told us, a tertiary carbon, carbon next to a tertiary carbon. So this is my carbon next to a tertiary carbon. Now this is my neopentane. Now let me make hydrogens also. So 3 hydrogens. Why? Because carbon is tetrahedral. So I will have 3 hydrogens on all of them. This guy will have no free valency. So this will have no hydrogen. Now, so degree of this carbon is 1 degree, 1 degree, 1 degree, 1 degree, and this carbon is 4 degree carbon. I hope now you know how to check the degree also. Now, if you remove any hydrogen, sir, you remove any hydrogen, sir, name will come same. Let's say if I remove any hydrogen, it will be same. If I remove any hydrogen, the name will be same. Let us practice names also. Let us practice IUPAC naming also, because NCERT said isomerism and IUPAC. So, sir, this is 1, 2, 3. So methyl. So its name will be, sir, 1 chloro, 1 chloro, 2,2 dimethyl, and after that I have 3 carbon chains, so propane. Yes, sir. So definitely you can substitute any hydrogen and you will get only one mono substituted derivative. That means that this is definitely correct. Now, melting point of neopentane is higher than normal pentane. Yes, sir. Boiling point of normal is higher because in order to boil, you need a liquid. Liquid largely depends upon the surface area. But sir, for solids, compactness gives symmetry. The more symmetric you are, the more easily you can be accompanied as a solid. That's why definitely, sir, because neopentane is more symmetric, therefore definitely it will have more melting points. Are definitely, sir, this is JEE Mains question. So NCERT word to word they are asking. So obviously, sir, this is also correct. That means, sir, both the statements are correct. I hope everybody is with me on this. Yes, Hamilton. Great, beta. Great. Chalo, perfect. Moving forward. Now, next question. Again, a good one. Common sense, but good one. Try, beta. Try. Quick. Try. The question is telling us which one of the following has minimum boiling point. Sir, boiling point has to be minimum. So in order to have minimum boiling point, sir, first calculate mass, sir. Beta, that is butane, isobutane, butene, butyne. Sir, carbon is same. Hydrogen has negligible mass effect. So ultimately all have 4 carbon. That means they are approximately similar massed. So first boiling point is compared using mass. If mass is same, that means if I'm having comparable mass, then you should definitely see the intermolecular attraction. Then you should go for intermolecular attractions. Okay, sir. Got it, sir. Now, sir, butane, sir. Butane is having 4 carbons, sir. Okay. Sir, no polarity, sir. Okay. Isobutane, sir, iso is first carbon, second carbon should have methyl branch. Sir, this is isopropane. So in this free valency I should add. So sir, this is iso 4 carbon, so butane, sir, this is isobutane, sir. Now what is butene, sir? Come on, yaar, sir. Butene is, sir, but 1 in the this is butene. What is butane, sir? 4 carbons, and at first carbon I should have this, so this is butane. Sir, this is sp hybridized carbon. I hope you know alkanes are sp3 hybridized. This is sp2 hybridized and this is sp hybridized. Sir, electronegativity of sp hybridized carbon is very large, sir, than sp2, and actually, sir, sp3 hybridized carbon is practically not at all electronegative, sir. Why? Because more be the s character, more is the electronegativity, because s character means you have more proximity with the nucleus. More, because sir, among s, p, d, f subshell, s subshell has penetration effect. It is deeply embedded in an atom. So that means it is most closest to the nucleus. Nucleus wants what, sir? Nucleus wants electron, and because nucleus wants electron, that definitely mean, sir, the species will be electronegative. So this sp hybridized carbon is highly electronegative. So because this is electronegative, so this will ask for electron and this guy will give electrons. So that means you have polarity. So polarity, so this molecule is polar and another molecule of this type will also be polar. So sir, they will have very beautiful intermolecular forces of attraction. And in fact, sir, these attraction forces will not be London dispersion forces, sir, because they are not instantaneous dipoles, sir. It is approximately permanent dipole. So this is a dipole attraction. I'm not saying dipole like a proper, but sir, in comparison to alkane, I can say this is dipole yet somewhat. And that too, this terminal hydrogen, sir, it will be highly polar, sir. It will be the delta positivity of this hydrogen and delta negativity of this carbon. It's so perfect, sir. It is very polar, sir. So who will have highest boiling point? Sir, obviously Delhi will have highest boiling point. But sir, question is asking minimum, but we are learning. We are not doing question. Question, so I am giving answer. I don't want you to give answer. That's why I have not used any poll. I want you to be comfortable with the logic so that this fear goes away. Arey yaar, JEE is very difficult. JEE is halwa. JEE is easy if you just stick to basics and enjoy learning. Do not have, sorry, but it will take a lot of time. You have complete year. You are class 12th. Class 12 students have complete year. So just relax and do whatever which makes you feel good. So enjoy and learn. Okay. चलो. हाँ, अच्छा ऊपर आंसर भी है. Yes, Neha. See, because this class, Neha, we are not here for, these are not class 12 pass students, Neha. So we are not here to practice. We are here to learn and enjoy. है ना? चलो, moving forward. Now, अच्छा. Quick. So, sir, D has highest boiling point, sir. Move forward, sir. Okay, beta, moving forward. Now, beta, butane. Why? Because, sir, alkene is also sp2, but actually sp, ultimately you are carbon. You are electronegative than sp3, but sir, ultimately that doesn't create that much of polarity, sir. But that we have to know. Yes, certain facts in organic. Ultimately, beta, you have to learn how you integrate lnx. Sir, 1 into lnx, we do by parts. So beta, what is it? You have not, you learn some conclusions. So learn these conclusions. Now, so sir, D, then you have A. Because you can say, sir, mass is more relatively. And then you definitely have C, and least is Bombay. Why least is Bombay? Because first you are an alkane. No polarity. Sir, you are an alkane. So no polarity. Plus you are having branching also, and because of branching, definitely boiling. I mean, it was very easy to come to the conclusion B, but it is quite becomes good and learn. I mean, yes, worth learning if you do this question completely. Like I am giving the complete order. This is a straight chain alkane. Yes. So definitely beta, straight chain alkane, even number of carbon, sir, more symmetry. So but sir, you said symmetry is for boiling point. So that's why if someone wants to have a clear cut picture regarding them, then I can definitely say this is quite factual. But yes, if you will grab my neck, I will say it has, this is butane. So this is C4H10. This is butene. So this is C4H8. What's are to only two hydrogen. So that's why I'm saying once you grab my neck, then I'll say okay, mass is more. But actually that's a fact which you have to learn. Okay. Sir, alkanes have slightly lower boiling point than their corresponding alkenes alkyne due to beta C. Hamilton, I told you they have polarity. So because of polarity, definitely you are right. They will have, but this is clear cut applicable for alkynes, not alkenes, because if you compare butane and butene, then rather butane has a high boiling point. Although this was not asked, this is also a JEE mains question, JEE 22004. But yes, although they have not asked the order, but yes, the order is butane has slightly more. So whatever the polarity thing, we generally we learn that. But beta see, like the density thing that you were talking of, see, there is a anomaly. There is an anomaly because butane has high boiling point. So yes, there are certain things that you have to write in your copy so that it can be with you for longer duration of time. है ना? Chalo, moving forward. Now, next question. Again, sir, practicing IUPAC and isomerism. So perfect question to practice it. Obviously given you the answer, but I want you to be practical around it. So attempt this one. You have to give the total number of isomeric compounds. Quick attempt. Just take out your pen and copy and try to write the structures with the name as well. Quick. Sir, I am class 9th. Acha, Hamilton, you are in class 9th? Oh my God, seriously? Great champ. Great, champ. Great. Great. Chalo. Let us attempt this one. The question says the total number of isomeric compounds, including, you have to include stereoisomers. Now, what are stereoisomers? Geometrical and optical. Geometrical are generally restricted rotation, like an alkene, different orientation in three-dimensional space. Optical are, sir, optical are those isomers which have different ability to rotate the plane of polarized light. Why do they differently rotate plane of polarized light? Because they have some asymmetry in their structure. So because of that asymmetry, I will catch the light, and because my symmetry is asking me, so I'm throwing that light to left side. If the another person has exact opposite symmetry, so we will catch the light, but it will throw that side. So ultimately the plane of light is polarized in different sense. It may be dextro-rotatory or it may be levo-rotatory. Okay. Chalo, yes, 6, yes, Hamilton. Now, so you have to include stereoisomer on monochlorination of 2-methyl butane. So what is 2-methyl butane? So butane as in 4 carbon. 2-methyl as in second carbon is having methyl. I'm not adding those hydrogens. You can very well understand, because that creates, no, that removes beauty from the from the possibilities. So, sir, monochlorination as in you just do, sir, you take 1 carbon and you substitute chlorine. Okay, sir. So, acha, but I have to think of the possibility. So why? I know you know, I know that everybody knows chlorination means remove hydrogen and add chlorine. So rather let us not waste time and take this picture and try to put chlorine into this. Sir, if you add, let me draw this few times. So if you just take this carbon or this carbon, if I add chlorine here or here, name will be same. What will be the name? Sir, 1-chloro 2-methyl butane. I hope everybody is clear. So this is structure number 1. Now, structure number 2 will be, sir, these two options are gone. If you take chlorine here, so this will be 2-chloro 2-methyl butane. I hope everybody is clear. Sir, these two options are done. This one is done. Let us check for this one. So third structure will be, I will add a chlorine here. So this will be 1, 2, 3, 4, because both are branch, so 2 can be here also, here also. Lowest location is tied. But yes, sir, chlorine is starting from a C, so rule of alphabetization will say this should be 2. So, sir, this is the third structure. And fourth structure will be, if I add a chlorine over here, so this name will be 1-chloro 3-methyl butane. Why you have drawn more, sir? Because I have only included the structural isomers. These are all having same molecular formula but different structural formula, because their name is also different. So these 4 are my structural isomers. Sir, I have to include stereo also. Sir, there is no alkene, there is no geometrical stereo center. Alkene is generally a geometrical stereo center, although we have more geometrical stereo centers. But yes, sir, we will study the relevant things of GOC, not everything, because then time will be, but sir, gradually everything will come. Okay. So, sir, but check optical isomers. What is the best example of an optical stereo center, sir? Chiral carbon. What is a chiral carbon? An sp3 hybridized carbon which has all 4 differently substituted bonds. So let us check in every compound that whether some chiral carbon exists or not. In order to check beta, just try and draw hydrogen. So 3, 2, 2. If you're having more than one atom, obviously you are not having all 4 different bonds. But yes, sir, this is having CH, sir. So this carbon having 1 ethyl, 1 methyl, 1 chlorine and 1 hydrogen. Sir, this is chiral, sir. Yes, beta. So if this is dextro, because I do not know, it is chiral, that means it will have 2 brothers. One will rotate light in clockwise direction and one will rotate light in anti-clockwise direction. It will be one of the brother. Let's say this is dextro-rotatory, so it will have a brother who will be levo-rotatory. Hello? So that will be my 5th isomer, although 1st and 5th are stereoisomers, optical isomers. Now let us check more. Sir, here this is H3. Sir, this, but it is having two methyl groups and both are same. This is H2, this is H3, so no optical isomer. What about this guy, sir? Sir, this is CH3. Sir, this, sir, this will have one hydrogen, sir, methyl with this isopropyl chlorine, and sir, this is also chiral, sir. So because this is chiral, if it is dextro, its brother will be levo. So this forms the sixth one. And obviously this has no chiral carbon because H2, sir, it has H but it has two methyl groups, so both are same, and obviously they have H3, so this will also have no optical pseudocenter. So in total you have how many isomers? 6. So a perfect question to practice IUPAC also, to practice structural isomers also, to practice stereoisomers also. Good. Rank 1 आएगी तब तो इनकी है. Neha is taking maja, and he knows more than what. Acha. हाँ, yes, okay. Then people are, yes. Hamilton, beta, if you are class 9 student, beta, we all are clapping for you. Great, my friend, great. Proud of you. God bless, my friend. Yes, definitely sleep, beta. Okay, chalo. Moving forward. Next question. Sir, sir, move theory, sir. This is alkane, sir. We have to read till alkyl halide, sir. We be quick, sir. Okay, beta. Let me increase a bit of my speed, because now I hope everybody is in sync with me. Next comes is preparation of alkanes, sir. You have told in NCERT also. First, some properties, so physical properties, and then sir preparations. So starting with the preparations of alkanes. How many preparations NCERT had? 3, sir. First one was, how many preparations NCERT has? 3, sir. So first one was Satish, sir, JEE dropper or MTech at IIT, which is better to do? JEE dropper, beta. Satish, no doubt. MTech, beta, please. JEE dropper is much better. Nikhil, acha, Nikhil is doing peer-to-peer chalo, peer-to-peer doubt solving. Now what topic? When alkyl halides. Beta, just it will start, because as I've already told you, no just. First I'll be doing alkanes, then alkenes, and then alkyl halides. Okay? Chalo, now. Preparation of alkyl halides. Preparation of alkanes. So see, this topic will be related to alkyl halides also. So how alkanes are prepared? Sir, first we are learning about from alkyl halides. NCERT has also given this from alkyl halides. Now what are the methods to form an alkane from alkyl halides? The first one is using reducing agent. These reducing agent I am referring as RA. So if I have alkyl halide and if I use reducing agent, then sir, from class 9th, 10th we know reducing agent basically mean one reagent that will add hydrogen. So this reagent will give that hydrogen, and that hydrogen will be substituting the halogen, and you will be getting your corresponding alkane. Now what are these famous reducing agents? Beta, NCERT discuss only this. Zinc in acidic medium. Now because you need a weak acid, so you can even use dilute mineral acids. You can even use organic acids, because ultimately number of H plus ion you need is very less. Sir, you can use base also. Why? Because sir, zinc is an amphoteric metal. It can react with acid also, base also. With acid, it will form salt and hydrogen gas. With base, it will form sodium zincate, Na2ZNO2 plus hydrogen. So again, this is a class 10th knowledge that zinc is amphoteric, so it can create hydrogen, and that hydrogen can reduce. So yes, in NCERT only this thing is there. That's why I've changed its color. But actually, in general sense, you should know some more facts. So walking one extra step for each. Now, sir, zinc copper alloy. The alloy made by copper and zinc can also be used using ethanol. This can also act as a reducing agent. Some other reducing agents are, famous one is lithium aluminum hydride. It is a very strong reducing agent, obviously gives H minus, so a very powerful reducing agent, but yes, quite expensive. Now, sir, how the reaction will proceed? Beta, quite easy. I've already explained in the so I'm giving you direct conclusions. A beautiful page. Sir, bromine will be substituted, hydrogen will be coming. Now, sir, that means this will form 1 degree forms ethane. This is a 2 degree halide. Sir, it will also form an alkane, but this hydrogen will be added to the 2 degree carbon. So this will be propane. And this 3 degree alkyl halide will be forming. Now, this is a fact. Why? First point is, although NCERT do not give this detail, but you should know some common sense. What common sense, sir? If you have an alkyl halide which is 3 degree, so with 1 degree and 2 degree alkyl halides you can reduce and form alkane, but 3 degree alkyl halide rather shows elimination, because we will be learning this in alkyl halide, that alkyl halide, once it is 3 degree or rather substituted, it prefers to form an alkene, because the alkene formed will be highly stable. Why it is very stable, beta? Because it is having 3 hydrogens, 3 plus 3, 6 hydrogens, which will be stabilizing this alkene via hyperconjugation effect. What is hyperconjugation effect? Sir, the sp2 hybridized carbon are having alpha carbon as sp3 hybridized carbon, and these hydrogens carried by these the hydrogen carried by these carbons can give their sigma electrons to this electron deficient sp2 hybridized system, and thereby, because of donation of that sigma pi conjugation, the hyperconjugation, this alkene becomes quite stable. So if I am given a chance to form a stable product, why will not I form that product? And hence 3 degree alkyl halide, rather than giving simple substitution reaction, they shows elimination and rather forms an alkene. Sir, won't you give more detailed mechanism regarding elimination? We will definitely, but yes, that will be in the chapter of alkenes and alkyl halides, which we'll be doing later. Cool. Chalo. So, sir, summarize, sir. Alkyl halides are forming alkane of the form RH with zinc in acidic medium. These are some more options by which you can do the reduction. You can use strong reducing agent also, which is LiLH4, but with only 1 degree and 2 degree alkyl halides. 3 degree will rather use that reducing agent, but rather will give not substitution but elimination reaction. I hope everybody is clear. Moving to some more reducing agents. Sir, some more reducing agents are red phosphorus and HI at a temperature which is elevated. This is also a reducing agent by which you reduce your glucose and form a 6-membered carbon chain, a very famous and strong reducing agent. Next is, sir, magnesium in dry ether followed by hydrolysis. Now this is very important, so let us revise this as well. Let me give you an example. If I have, let's say, ethyl bromide. So this is an alkyl halide, sir. This on reaction with magnesium, because magnesium is a strong reactive metal, so rather I use an organic solvent, else magnesium will react with water. So what solvent I use? Ether. Now, sir, because magnesium is highly electropositive, so this electropositive guy will come in between, because it needs electrons from whatever possibilities it has. So it will come in between and form this compound, which over here it is having covalent nature and over here it is having ionic nature, and this compound is having 50% ionic nature and 50% covalent nature. And because of this discovery of the compound, this the scientist was even given a Nobel Prize, and this compound is called Grignard reagent, a very famous one. This is called Grignard reagent. Now, because, sir, you have already told us that this magnesium is highly electropositive, so it will be keep on searching for any possible negatives. So once after formation of this Grignard reagent, I introduce water. So then water is quite polar solvent. Definitely agree, beta. So the minus of water will obviously be attracted by the positivity of magnesium, and oxygen will drag 1 electron from hydrogen, creating H plus ion. So these H plus ions will rather go to CH3, CH2, and the hydrogen given by water will be added here, while the byproduct will be magnesium already having this electronegative species, and recently it has been introduced by the OH of water. Thereby this H of water is given to this ethyl group, forming alkane. So, sir, alkane is ultimately produced here also. So definitely a very famous method for formation of alkanes using alkyl halide. Again, this is also acting as a reducing agent because ultimately it is adding hydrogen. But yes, NCERT in alkanes only discuss about zinc in acidic medium, and because NCERT discuss about zinc in acidic medium, so let us do the mechanism also. What is the mechanism by which zinc in acid works? Sir, this is CH3, CH2, let's say any halogen. So again, bromine, because I've taken that example only. Now, what does it do? Sir, first it reacts with zinc. Now, what does zinc do? Sir, zinc is a metal and this metal can easily give electron. So metal will give electron. Once electron are released, beta, any reaction in presence of metal, what type of fission is preferred? Homolytic fission. So seeing these extra electrons, homolysis will take place. What is homolysis? Sir, homolysis mean this carbon and this highly electronegative bromine will take away their electrons and form radicals. So here I have formed an ethyl radical, and here I have formed a bromine radical. The moment these radical will see these coming electrons, they both will take 1 1 because electron is in excess. So this also will take electron because ultimately this is also electron deficient, sir. So sir, it will be forming, this guy will be forming by having this extra electron a minus, and similarly sir, this guy after receiving that extra electron will also form a minus. Sir, both are minus, and post, because you have H plus also, zinc in acidic medium, so that H plus will now form CH3, CH2, and that H, that means I have methane, and obviously with that H plus this will rather form HBr, but I am interested in this. So this is the mechanism by which zinc in acidic medium will work. I hope everybody is good. Now, perfect. Moving to the next one. Now, so next method of preparation of alkyl halide is through Wurtz reaction, sir. Now, what is this Wurtz reaction and how it will be functioning? Sir, alkyl halide will react with sodium in presence of dry ether and form alkane of the form RR. That means higher alkane is produced. That I have written over here, that symmetrical higher alkanes are formed with even number of carbon atom. Why even? Because sir, if it is odd, then odd plus odd is also even. If it is even, then even plus even is also even. And because double carbons are forming, so methane and odd number of carbon alkanes cannot be formed. Sir, very common sense. Now, let us do an example to understand this common sense. So the question is tertiary butyl. So what is butyl? Tertiary as in 3 degree. So if I have a 3 degree carbon and it has a free valency, and this free valency is substituted by a chlorine, this becomes my tertiary butyl group. So again, you just have to do this. So in presence of sodium and dry ether, so this R will be used in presence of sodium and dry ether. So this R will be used and it will be coupled with another picture of this sort. So C, 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 C. So what you have formed? Sir, I have formed a symmetrical alkane, because if you draw a line, it will be dividing the molecule into 2 halves. So this is a symmetrical alkane. Now what is its name? Let us practice naming also. 1, 2, 3, 4, as in 2, 2, 3, 3 tetramethyl butane. I hope everybody is with me on this. Now, moving to the basic mechanism of Wurtz reactions are here. This also will be same, sir. Sodium. The sodium will give 1 electron. The sodium will give 1 electron, and after giving that electron, sir, this electron will be trapped. Will be trapped by what? Sir, you have alkyl halide, sir. Halogen is electronegative, sir. So after seeing this extra electron, sir, obviously homolysis will take place. You have already told us that in presence of metal, homolysis take place. And because zinc was having extra electron, but here there is availability of only 1 electron, halogen being electronegative will definitely take this extra electron and will form X minus. And poor guy, poor R, will not be getting anything, so it will be remained as a radical. So this is your alkyl free radical. But sir, this can happen n number of times because you have molecules, more and more molecules. So because I have more and more molecules, so more and more R will be formed. If more and more R's are getting formed, then this R and that R will attract each other. This radical and this radical will definitely have what? So they will simply have chain termination. They will simply have same chain termination, as in this R, okay, I'm sorry, as in this R and the white colored R, both will do chain termination. Radical of this carbon will form an RR. So sir, obviously I can understand this also, and with this we are predicting the mechanism also, which is homolytic fission, and with that free radical is getting substituted by another free radical. Hope it is good. Chalo, perfect. Sir, you are going to cover reaction. Beta, this is what very difficult name to read. So let me read the last four word edits. So Z as edits. Beta, this is what I already communicated in the beginning. Whatever NCERT thing I'll be picking, I'll be discussing the complete mechanism along with it, because this is what makes you confident regarding NCERT. Cool. Chalo, perfect. Aha, Savita is saying perfect. Chalo beta, perfect Neha. Chalo, moving to the next one. Sir, is learning this much regarding Wurtz is good? No beta. Add up, because yes, advanced loves it, so mains also started loving it. So now we are moving one step more from NCERT in per se Wurtz reaction. Why? Because Wurtz reaction has some limitations. What are these limitations? Because you remember the free radical substitution page of NCERT was, again sir, one complete page was given to free radicals substitution mechanism. That means NCERT is also discussing regarding it. So that's why we should also have in-depth analysis of it. So one of the limitation of Wurtz reaction is if you use mixture of alkyl halides, as in I have methyl bromide and I have ethyl bromide, then obviously sir, the possibility of this radical and this radical will be more. So possibility of their getting chain termination will be more. Why? Because this is more and this is more. Sir, intermediates collide and they do chain termination. So who is colliding more? Whose percentage is more? So this and this percentage will be more. So I am not denying to the fact that who will be major product. Sir, when methyl will be hitting, getting chain termination with ethyl. So what are you forming? Sir, I am forming propane. But yes, this will be formed in more percentage also. It will be the major product only. But limitation is percentage yield will be very less. Why? Because sir, there will be mixture of n number of products. Sir, why more products? Sir, possibility of this is more, but you can't stop methane and methyl radical also having chain termination. No, I cannot stop that dimerization. Sir, ethyl radical hitting, no, I cannot stop that as well. So much percentage will be wasted, although I'm not saying this will be your major product, but percentage of this major product will be very less. Let's say 50%, 55%. So sir, if you are running a factory, then 50% efficiency, 55% efficiency is not good, sir. So you will be getting ethane as in dimerized product also, and you will be getting this also. What is this, sir? You have written disproportionation product. Yes. Sir, explain. Okay, beta. So explaining the bottom two, you know. Now, why this, sir? Suppose you have ethyl radical. I'm intentionally making this hydrogen separately. Why? Because, sir, if you have ethyl radical, then this radical can also be undergoing homolysis. I can't only have homolysis initially. Sir, homolytic fission is a very strong phenomena. You can't stop and limit all the Every bond that you will not have homolysis, only you will have homolysis. No. So once a radical is produced, it is an intermediate, it is highly energized. So can't it have self homolytic fission also with C and H? Yes, sir. Now, if it does have self homolysis, or rather, because this guy is already having radical, so let me not do homolysis of this guy. Rather, in fact, let me do homolysis of this guy. How, sir? Because this ethyl radical, if it is approached by another ethyl radical, this is one ethyl radical, this is one ethyl radical, they can have chain termination, and dimerize. But what if, sir, the orientation, sir, how will they will have this chain termination? There are balls revolving, ball hitting. Can you stop the probability that this will hit this way? Sir, maybe. So if it is hitting this way, it will be dimerizing. But if it is hitting in opposite sensor, it won't be dimerized. Then what it will do? So this ball, when hit this ball with opposite orientation, what will happen? Sir, homolysis, as you were saying, but yes, do the homolysis of, because this radical will come, so bonds will break. But what bond will break? Sir, because it is approaching in another way. So let's say, sir, this will get homolysis. So now you can see, if it is getting homolysis, then for this CH2, getting this H is easy, or that getting that C is easy. So getting that this H is easy. So ultimately this ethyl radical will be this H radical. It will have chain termination, and it is your ethane, plus this guy who has recently got another radical. Why it will bother? Because it can have chain termination within the molecule only. It do not even have to rush outside for in search of love. It is getting love inside only. That means, sir, this chain termination can take place within the molecule, and now what is formed, sir? Ethene. But sir, you are saying disproportionation. Remember the basic definition of redox reaction. Reduction is addition of hydrogen. So in this radical, is hydrogen adding? Yes, sir. That means it is my reduced product. That means it is my reduced product. Is this guy, from this guy, hydrogen is removed and it is formed? Yes, sir. Removal of hydrogen is oxidation. That means it is my oxidized product. So if chain termination, that is both radicals being in kinetic energy hitting each other. So if this hitting take place when radical has approached each other, dimerization take place. But if hitting is opposite sense, then data disproportionation will take place, which is oxidation and reduction. It is a very clear and a very good example for learning the other type of products, which is decreasing the percentage yield of a product when you have Wurtz reaction using mixture of alkyl halides. I hope everybody is clear, guys. Perfect. Chalo, great. Moving to the next one. Now, sir, again, that it is not given in alkane, sir, beta, but I'm teaching alkyl halide. And once you are discussing alkyl halide, because we are discussing halides, so aryl halides can also react. But sir, whenever you have aromatic halide, this halogen and this benzene are in love with each other. Why? Because the lone pair of electrons because the lone pair of electrons on chlorine will force these electrons inside the ring. Hence, this bond will have a partial double bond resonance stabilization. Sir, if a bond is stable, the possibility of this bond breaking will be less. But yes, you have already communicated to us that sir, homolysis, whenever it take place in a very drastic condition. So whenever you are using metal, this metal don't even care that whether the C bond X is strong or weak, because rather homolysis is always very drastic. So even if you have a more strong partial double bond character, still you will break. So all the reactions of alkyl halide and aryl halide are not same, but reaction with metal of alkyl halide and aryl halides both are same, because homolysis by nature, homolytic fission by nature is quite violent. So this violent reaction will take place. This sodium will take up chlorine of both of them as it is doing with alkyl halide, and this compound and this carbon chain, this phenyl and this phenyl will do chain termination. And what are you going to produce? So just like alkane, I am producing aromatic compounds. So this is biphenyl, but this was not given to the science community by Wurtz. This was rather rectified by a scientist named Fittig, and hence this is known as Fittig reaction. Once you take aryl halide and react with alkyl halide, so you get a which is alkyl benzene. Same thing is happening because homolysis doesn't care you are alkyl halide or aryl halide. So radical will be formed and radical termination will be taking place, and again cross product will become the major product. I'm not again denying to the fact that the percentage yield will be less, but still if you are asked in the question what is the major product, then the cross product is the major product, which is alkyl benzene, and this reaction is termed as Wurtz-Fittig reaction, a very important point from NCERT as well. Yes, not in the chapter of alkyl halides, not in the chapter of hydrocarbons, but yes, definitely in the chapter of alkyl halides. Now, there are few more reactions, yes, because they have been very less frequency, but yes, they also have been came in purview of examination. So yes, some extra reactions. First one being Ullmann reaction. The same thing is happening with iodobenzene. Why only iodo, sir, specifically? Because beta, as you have already seen that this bond is stable partial double bond character, and I'm not using a very reactive metal. Sodium is a very reactive metal. These copper is a D block, so very less reactive. So I need large bond length. So rather it takes place with great percentage only in case of iodobenzene. But yes, if you use iodobenzene with copper, the same reaction happens and you get biphenyl. How to remember this? Ullmann is starting with a U, copper is U, the U, 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 U. So you can remember this using this U format. Perfect. Now, next, Franklin reaction. Nahi Neha, nothing has been leaked, beta. Please, you are a very serious student. So don't try and don't create these rumors. No, I mean, yes, not even for fun, beta, because see what has happened to everybody. So I mean, nothing of that sort has happened. If we get any of those news, obviously we will be the first who will be telling you that. Chalo. Now, sir, one more reaction, Franklin reaction, the same thing which Wurtz said. It can also be done using zinc, but given to the science community by a scientist called Franklin. So this is called Franklin reaction, forming alkane of the higher alkane of the form RR. Moving to the next one. Now, sir, that means, sir, you have given so much of detail regarding alkyl. Let us summarize this. So if you remember, if you can, then try to remember everything. Else, just be precise, because if good question comes, then you will be requiring those details. If basic question comes, then this much is sufficient. What is, so let me summarize just for mains what you should know. With alkyl halide, you can form alkane. If you are using sodium and dry ether, then sir, higher alkane. So this is my R, which is ethyl. So ethyl bond ethyl, that means I am having butane. Sir, if I'm using zinc and acidic medium, the only reducing agent which NCERT suggests, sir, then just remove halogen and add hydrogen. That means I'm forming an ethane. So if anything is more becoming very difficult for you, just this point will help you to have an idea what is actually written in NCERT. NCERT only give this. NCERT only give this. Let me show NCERT. NCERT for preparation using alkyl halides only give you this information. Now that is why you should have, you need addition on NCERT. See, alkane, alkyl halide with zinc and acidic medium form alkane. Alkyl halide with sodium in dry ether forms alkane of the higher form. That's it. These 3 lines and this is done. Now see how much detail we actually need for a JEE level of student. So yes, you should learn, you should definitely read as per NCERT, but you have to, at the same point of time, you have to enhance your knowledge, enhance your skills regarding the data given in NCERT. So this is what we mean by this series, that NCERT based JEE preparation. I hope now after completing one topic, at least we have an idea that what we are planning to and intending to do over here. Cool? Cool? Chalo, perfect. Moving to next one. Sir, next is from unsaturated hydrocarbon. So if you want to create alkane from unsaturated hydrocarbon, then this rather you have been knowing this from class 9, 10th. First thing is dihydrogen gas adds to alkene and alkyne in presence of finely divided catalyst like platinum, palladium, nickel to form alkane, and this process is nothing but hydrogenation. Okay, sir. These metals adsorb hydrogen gas on their surface and activate the hydrogen bond, as in the solid surface adsorb the gas and then the reaction can take place easily. Platinum and palladium catalyze the reaction at room temperature. That means that they are more activated catalyst. Hence, you do not have to elevate the temperature, but relatively higher temperature, you have to increase the temperature and pressure once nickel is used. Obviously, the platinum palladium is expensive, so the catalytic action of platinum palladium is quite large, so you can do that reaction even at room temperature. But with nickel, you have to, if you want to do hydrogenation, you have to elevate that temperature. A detail given in NCERT, so important. Moving forward. Now, sir, basic, sir, this we know from class 9, 10th. So let us quickly make the products. Sir, ethene is generally named as ethylene. Hydrogen, so see nickel, so heat is given. Now you will be getting your ethane, sir, easy, sir. Butane will be forming 4 carbons, alkane, as in butane. Acetylene, 2 carbon, alkyne is generally in acetylene. Some extra point, instead of nickel, sometimes nickel is given. Do not worry, because nickel is also that nickel, but it is crushed. Once crushed, so surface area increase, so it is also activated. So because activated, so even at lower temperature you can do, you do not have to bother about heating. But crushing nickel very properly to a high extent, fine refined, sir, that money will be required. So save money on heating. So industry, a better process of, instead of nickel, you should run a nickel. Ultimately, product is same. I'm just doing the hydrogenation. One extra point, whenever hydrogen is added to alkene and alkyne, hydrogen are added from the same side. Same side addition is known as syn addition. So whenever you form alkane or saturated compounds from unsaturated hydrocarbons, the addition is happening from same side. Whenever addition are happening from same side, such addition is known as syn addition. I hope everybody is clear. Next. Now, next preparation of alkanes are from carboxylic acids. Now, how you can form your alkanes from carboxylic acids? NCERT gives you 2 methods. What are those 2 methods? So first method is soda lime decarboxylation. Just this much. Second method is Kolbe electrolytic method. They give detail in at least in a page. So let's say at 25% of the page they give detail regarding the mechanism also. Why? Because this also relates with the common sense of Faraday law of electrolysis, as in yes, or not Faraday specifically, but yes, electrolysis you read in 2 ways: qualitative analysis, as in how much is produced, and quantitative analysis, as in how it is produced. So we also have to do the quantitative and qualitative analysis. Now let us see how. Can you Sir, can you explain once again that previous page? Sapna, what previous page, beta? Sapna? Chalo, by the time I'm continuing, I guess by the time Sapna you can write that precised out, then definitely I'll be referring to it, है ना? You can write that precised out, I'll be picking that exact out, है ना? Chalo. So soda lime decarboxylation. What is soda lime decarboxylation? Sir, soda and lime. Actually, the reagent is soda. So the soda and lime is used in the ratio 3:1. As in, if I have 100 gram of mixture, so 75% it will be soda and only 25% will be lime. Why? Because lime is not my active reactant. Lime is just used to keep the reaction mixture dry. Why you have to keep the reaction mixture dry? Because I need no water. Why I do not need water? Because I have this NaOH, which is highly polar molecule, an ionic compound, a base. If it gets water, it will react with water and will leave this poor organic compound. That's why I do not want any water to enter my territory. I do not want any water to enter my territory because NaOH is hygroscopic. What is hygroscopic? As in, I can even absorb moisture and can react with it. So those NaOH will not be remaining, and hence to avoid any addition of water, I use a dehydrating agent, which is calcium oxide, which has high affinity for water. So even if it is moisture, it will absorb that moisture and will not allow water to interfere in the reaction. Now, what is this reaction? So reaction is very simple. You just can learn, even in mains or advanced level of question, you can learn this dabba method. What is this dabba? You create a box. Decarboxylation mean, what does decarboxylation mean? Decarboxylation mean removal of CO2. So this CO2 being an acidic oxide, it reacts with base, and with this base salt is produced, which is Na2CO3. Ultimately what you are left with, sir, R of carboxylic acid, H of NaOH, forming alkane RH. Now for mains level of question, you do not need mechanism. But yes, still giving you mechanism for this. Acha, okay. Sapna is asking that sin something. Okay. Beta, whenever you have unsaturated hydrocarbons and they are added with reactants, so the addition can take place from the same side or it can take place from the opposite side. So if it is taking from the same side, such an addition is called syn addition. When you can have that syn addition, when generally the adding molecules are very small, and when you have anti addition, when the coming adding molecules are large enough. So technically, when the adding molecules to an alkene or alkane or alkyne forming an alkane, I beg your pardon, again I'm repeating, whenever you have unsaturated hydrocarbons like an alkene or an alkyne to form saturated hydrocarbons or saturated compounds, because after addition you may be hydrocarbon, you may become another compound, ultimately you will be getting saturated, that pi bond will be gone. So pi bond will be required some addition. If addition is happening from same side, it is syn. If it is happening from opposite side, it is trans. Generally, small species like HH add from same side. Yes, not generally, as in hydrogenation is always syn addition. But yes, we will be seeing more addition, which will be opposite as an anti-addition. So for some good questions, you should know this also. So that this is syn addition. Moving forward now. Sir, please discuss about the mechanism, sir. Very basic mechanism. Let's say I have RC double bond O minus, because I was having salt of carboxylic acid. I was having this salt of carboxylic acid, and this salt of carboxyl, salt means it can dissociates a plus and minus. So let's say I have this RC double O minus. Now this RC double O minus will do what? So this can easily transform. Once it is transforming, this R can snatch the electrons. If it, I'm not saying this will be happening very properly, but yes sir, in presence of the reagent this can happen. As in, this R will be R minus and CO2 gas will be released. Now this, I'm not saying, you are saying, sir, from this sp2 hybridized carbon, this carbon is taking electron. No, this carbon is not taking electron because of its power. this carbon is taking electron because this guy wants to give. Why this guy wants to give? Any reaction can become reverse, can go in forward direction if you remove the product. This CO2 gas wants to be produced because it is being called, it is being invited to a party. It loves to party with NaOH. Why? Sir, because you already told carbon is in +4 oxidation state, so carbon dioxide is an acidic oxide. And this acid will definitely want, it will be loving to join the party with this base, and therefore what is formed? Sir, Na2CO3. And because this is precipitated, so this is precipitated and the reaction is forced to proceed in forward direction. I am not saying this R is getting and taking and snatching the electron because of its power. No, this oxygen is feeling happy to give away the electron because it is not ultimately just forming CO2. It is dragged by NaOH to form a precipitate. So if you remove the product, even a reaction which is not trying to move in forward direction, it is fractionally moving in forward direction, but still, according to Lee-Chatelier principle, the reaction will be forced to proceed in forward direction. Thereby, formation of this R minus will take place, and this R minus will take H plus given by sodium carbon with this reaction, this H, and this R minus and H plus will be forming alkane. But look at this alkane beta. Whatever be the carbon parent chain of this carboxylic acid, this alkane will be having one carbon less because one carbon has been removed as CO2. I hope everybody is clear with the mechanism also. Now, sir, why you are telling this mechanism? Because if somebody is asking you that among formic acid or acetic acid, which acid can go soda lime decarboxylation with a faster rate, then you have to do experiment. Sir, I can't do experiment. I am a science student, I am a JEE student, I have to apply some common sense. You tell me what intermediate is produced? R minus. Sir, carbanion is stabilized by what? Electron withdrawing group. That's what carbanion is formed. So electron withdrawing group increases rate of reaction, or rather electron donating group will decrease rate of reaction. So this CH3, okay, let me do substitution also because this CO2 will be removed. So let me frame another question for you. Let's say CH3 and CH2, let's say fluorine. So this fluoro derivative of acetic acid or acetic acid, which will show decarboxylation reaction with a faster rate. So this F minus will stabilize this carbon ion, this. And that's why this will be having a faster affinity towards formation of alkane. So which carboxylic acid will have more affinity to form alkane? So that one. How we can do that, sir? Only once you know the mechanism. I hope everybody is good. Huh? Congratulations, sir. Century, okay, century minutes completed. Okay, beta, thank you very much. Congratulations to you too. Chalo, moving forward. Sir, what is the next preparation, sir? Beta, from carboxylic acid, you can also prepare using Kolbe electrolytic method. Again, sir, NCERT fact. So what is this Kolbe electrolytic method? Let us explore this also. So Kolbe electrolytic method simply tells us that if you use sodium salt of carboxylic acid as in soda lime decarboxylation, but yes, it can be sodium also, potassium also. If you put the salt in water, sir, salt can easily dissociate in water because salt is a strong electrolyte. Now, electrolysis mean you are passing electricity. Once you're passing electricity at anode and cathode, these are the products you are forming. But now, because NCERT is giving the complete mechanisms, obviously we also have to give. Now, let us give mechanism to this. So, sir, ultimately, what is the mechanism? Obviously, methane can't be formed. We'll see why. But first, look at the mechanism. Now, sir, ultimately, what is happening over here is, because you are supplying electricity, so first you need a battery, sir. So taking a battery of some voltage, because this positive terminal of the battery is connected to this electrode, so this will be positively charged, this will be negatively charged. What I have in the sir, water is not a conductor, so you must have added salt. What is the salt? RCOO minus and Na plus. So plus will move toward negatively charged electrode, minus will move toward positively charged electrode. What minus will do, sir? Minus will give electron. So the electrode at which giving electron is oxidation. So the electrode at which oxidation take place is known as anode. So plus will go here and will ask for electron, as in it will gain electron. Gain of electron is a reduction, and the electrode at which reduction take place is known as cathode. So let us write the anodic and cathodic half reaction. So at anode, sir, electron giving will take place. Who will give? Sir, this, that means R, C, double bond O, O minus. Because this is minus, so it is having extra electron. It will give away that extra electron. The moment, let's say, this is the, these are the electrons. All electrons are paired. 1, 2, 3, 4. But I am unpairing this one. Let's say this is a pair. One electron I have got, and the extra electron that I had, I have given that electron, because this is the oxidation. So this oxidation is forced by the external battery. Okay, sir. So once it has given electron, so sir, electron is given now. But sir, radical has formed. Now you tell me, will this oxygen is happy to keep this radical? No. Now what it will do? It will create chaos. It will create chaos, and in that chaos, due to that chaos, this carbon will break the bond from that carbon. Why? Because the moment you have this C, which is having double bonded O, I'm making that double bonded O like this, which was initially single bonded O with this, but because of the chaos created by this electronegative oxygen, by getting this odd electron, it has asked this carbon to break the bond with alkyl group, and chain termination will form CO2. So CO2 is released at anode. Now what else, sir? Then I have this poor R radical. So this R radical can clearly react with another R radical of the same form, because another molecule will again release CO2, and you will form alkane of the form RR. But this is also a higher alkane with one carbon atom less, because one carbon atom is removed in form of CO2 and then doubled. In soda lime decarboxylation, it is just reduced to one carbon atom, but here it is reduced by one and then doubled. So yes, you have to know what is the complete mechanism in order to predict that CO2 gas and alkane are produced at anode. What about cathode, sir? Obviously, at cathode, reduction take place, and sir, Na plus will not take electron. Why, sir? Because Na plus is having complete octet, sir. It's a metal. Metal wants to give electron, and hence it has given electron. But what? So this reaction will not take place. So who will take electron? Sir, water can also take electron. You remember the competitive electron transfer. So here that competitive electron transfer is taking place, sir, and this water is taking that electron. And once that electron has been snatched and taken away, so what species will take that electron? Sir, hydrogen is in +1 oxidation state, oxygen is in -2. I'm not saying water is an electrolyte, but because electron is coming, so what part of hydrogen will take electron? Sir, hydrogen in +1 oxidation state. So hydrogen gas is removed, and once hydrogen gas will be released in water, hydrogen is gone as H plus, so it will be now forced to dissociate as OH minus. So in the solution, what you will be having, so this OH minus and this Na plus will be written as NaOH in the molecular form of the equation. So NaOH is produced at cathode, and hydrogen gas is liberated at cathode. So very famous reaction, beta. See, hydrogen gas and NaOH at cathode, and RR and CO2 at anode. Again, a very detailed mechanism, but beta, this detailed mechanism is definitely important. Definitely important, because NCERT invest at least 25% of a complete page. NCERT investing 25% of a page on a mechanism. So definitely this becomes very important. Cool. Chalo. One request. Yes, cute boy. Come on. So a question for everybody. By the time cute boy is asking some request, yes, beta, cute boy, come on, quick. By the time people can answer this, sir, is 98% possible if I start now? I'm a fresh dropper. I joined Laksh batch. Yes, beta, definitely. Huh? If star now, I'm fresh dropper. I joined Laksh batch. Beta, first thing is 99 percentile, 99.8, 99.9, 100 percentile. It is definitely possible. 1 year is more than sufficient, beta. I passed my class 12th in the year 2006. I was an MP board student. I had practically I was not even a CBSE student. We had no idea of solving numerical. We till class 12th used to do only theory. But yes, if you decide to do something, it is definitely done. I mean, there is no if and but. But yes, then you should not do any if and but with the number of questions you practice per day, the number of hours that you put in. So definitely you can. And if you join beta, but I guess uh, in Laksh batch also beta, yes, we will be completing class 12th and after that we'll be starting with 11th. So yes, definitely yes. No worries, Tushar. Hardly matters 12 months or 10 months. If you start, you will have a possibility and probability to end. If you do not start, there is no point of ending the race which you haven't started. So is it possible? Yes, it is possible. Have students done that? Yes, they have done that. Can you do it? Yes, if you work, you can. Sir, give kya? Ah, yes, Neha, rockstar. Akshat Sharma, sir, my organic is bit weak. Beta, then practice. See, am I rushing here? No, I didn't even intend to. Yes, I intend to give content in a manner which will make you happy. If you are actually here to, sir, but I am not getting those goosebumps. If you are actually serious about that JEE IIT seat beta, then you will be getting those goosebumps. This is the request. What is the request, beta? Cute boy is saying, give thick. What thick, beta? THICK. Sir, give thick. Cute boy, sir, one request. Then cute boy wrote, sir, give thick. And then option correct, ta calculate pana. Eh? Okay. This the request. You will get your dream, my dear. You will, definitely. NIT Trichy. Definitely, beta. Just start working from now. Don't wait. Chalo. Shall we proceed forward? Now. Sir, succinic acid. Okay, beta. Succinic acid plus sodium gives A. What is succinic acid, sir? Sir, 4-carbon carboxylic acid is succinic acid. So this O will give H plus and will form a salt. So O minus, this succinic acid with sodium. Okay. The question is asking you that also. So this is succinic acid. Once acid reacts with metal, what are you going to produce? A salt of that carboxylic acid. So salt of this carboxylic acid will be O minus and Na plus. O minus and Na plus. This is salt of carboxylic acid, as in this is my A. Sir, electrolysis, sir, we have done that complete mechanism. We definitely know, sir, this radical will be formed, and CO2 will be released. But I am asked B and C, where B is major and C is a minor product, and both are hydrocarbons, sir. It is not asking about byproducts. It is asking about B and C. Both are organic compounds. B is a major product and C is a minor product, where C is a cyclic compound. Hey, sir, cyclic compound? Beta, now think, because we have done the Wurtz reaction also. That's why you have an idea of free radical. So this radical, this CH2 bond CH2 having radical, sir, it can have chain termination within itself. Yes, obviously this will be more probable, and definitely this will be your B, your major product, that is ethene. But sir, you have told us if one molecule is approached by another molecule, obviously this probability will be less because within the molecule chain termination is easy. But sir, this will have a chance. Yes, less chance, but it will have a chance. What will have a chance? Sir, the radicals can undergo chain termination. And once they have gone chain termination, sir, this is cyclobutane, sir. If you check, this is cyclobutane. Yes, definitely minor product because this carbon wants to stay at an angle of 109 degree 28 nm because it's tetrahedral. But this Bayer strain will force this carbon to come in 90 degrees. So obviously, this will not be a stable molecule. But yes, you can't this molecule to be getting formed, and the cyclobutane will be a minor product. I hope everybody get that. Moving to the next one. So how we are summarizing this reaction with carboxylic acid. So just summarizing everything, although we have done bit of detailing also, but if you remember just this much is more than sufficient. What is it? Let's say I have propanoic acid as in 1, 2, 3, double bond O and OH. So this is 3 carbon carboxylic acid as in propanoic acid with metal or base, because carboxylic acid is a stronger acid than water, so it will form salt. So salt will be CH3, CH2, COO minus and Na plus. Now I am subjecting to electrolysis. So electrolysis will remove CO2, remove CO2. So I will create radical, create radical. So 2 carbon radical, 2 carbon radical, and then chain termination. So subtract 1 carbon, but then double the number of carbon members, as in butane will be your answer. But soda lime decarboxylation, sir, it will just remove CO2 in form of Na2CO3, and this carbon is not a radical, sir. So this is a carbon ion, and this carbon ion will get H plus from NaOH, and this will be just producing CH2 with an H. So this is nothing but ethane. So Bombay will be butane and C will be Chennai will be ethane. Perfect, Neha. Perfect everybody. Great. Chalo, next, sir. But in alkane, sir, there were only 2 preparations. But we are reading for class boards or for JEE, for JEE. Then couple the reactions. Although not in the chapter of alkyl halides or in the chapter of alkanes, but yes, very important logic, but in the chapter of carbonyl compounds. And these are the steps that you have to move with NCERT. So again, giving detail and coupling up with NCERT, but this is also an NCERT detail, but yes, given in the chapter of carbonyl compounds. Now, in the beginning, there were some students who were saying, sir, I cannot predict, I cannot recall what are the reagents. Maybe I remember them, but I cannot recall what are them. Why don't you, why are you not capable of recalling? Because you do not summarize everything. So this is the way that you should learn organic, is to summarize organic details. So you can even form alkanes using carbonyl compounds. How? By reducing those carbonyl compounds. Now, how these carbonyl compounds can be reduced? Sir, if I have aldehyde or ketone, as in if this is a carbonyl group, if it is having NEH, then this will become an aldehyde. If it is having both alkyl group, then it can be ketone. Now, sir, reduction as in addition of hydrogen. So if you add hydrogen here also, and if you keep on adding it, ultimately this oxygen will be removed and this carbon will be added with hydrogen and it will be forming CH2. But sir, for this you need a very strong reducing agent. Yes, definitely. What are these strong reducing agents? These strong reducing agents are even naming reactions are 2. First is Clemmensen reduction using alloy of zinc and mercury known as zinc amalgam in acidic medium HCl. That carbonyl carbon, whatever free valency it is having, just this oxygen will be removed and as water, and you will be getting corresponding alkane, whatever free valencies you have. Another reagent is Wolff-Kishner reduction, where you are supposed to react with hydrazine, and then after that you have to boil. You have to boil with what? You have to boil with ethylene glycol and in basic medium. So in basic medium, after boiling in ethylene glycol as solvent, what you get? Sir, you get the same thing, but this hydrazine nitrogen which has been added is removed in the form of nitrogen gas. So these are some extra alkane reactions which is there in NCERT and very, very famous, but they are producing alkanes, so I am teaching you them as preparation of alkanes only. Sir, prove it is very famous. So a basic question. Now this is how just point blank NCERT is asked you. Now this is one of the molecule. It is reacting with zinc amalgam and HCl. That means that it is Clemmensen reduction. Sir, this is ketone, sir, and this is aldehyde, sir. So obviously, what will be the product? Sir, it doesn't even matter whether you are ketone or aldehyde. You will also be hydrogenated. Yes, but you will be having 3 because one hydrogen it is having, it will get 2 hydrogen from there. So this carbon will become CH2, 1H it is already having. What about this carbon? Sir, it is having a methyl group, but this carbon will get CH2. So this carbon will get CH2 and it is already connected with a methyl group. So this will be my answer. What will be its name? So obviously ethyl having 1 because by alphabetization this is starting with an E. So this will be 1 ethyl, 3 methyl, and then benzene. I hope everybody is with me on this. Now, what else, sir? Beta, same question. Now here, this is JEE 2024, this is JEE 2021. Which of the following reagent is suitable? Okay, there were options, but I'm just asking you without giving you the options. I have a carbonyl group, although this is not benzene. That was benzene, this is not benzene. So this carbonyl group is connected to this carbon and not belonging to aromatic ring. So it can definitely be reduced. But sir, this is alkene and this is alkene, and Clemmensen and Wolff-Kishner are only reagent to reduce carbonyl group. So if you want this carbonyl group to become CH2, then you can choose even Clemmensen reduction or Wolff-Kishner reduction. So obviously one of them will be there in option and you just have to take them. See, this is the beauty of JEE, that they ask direct questions from NCERT moving forward. Now, sir, we have done, sir. What? Sir, preparation. Then what? Beta, then we have to move to alkene, sir. Then we have to move to, yes, Wolff-Kishner reduction. Perfect, Neha. Then we have to move to, after preparation, sir, we have to move to reactions. So let us move to reactions of alkane. How you can justify those reactions of alkane, sir? Easy, sir. Why? Because first one you already told us, sir, substitution reaction. Now, substitution reaction, technically you can have nitration also and sulfonation also. Nitration using HNO3, sulfonation using oleum. Oleum is mixture of H2SO4 and SO3. Nitration, because it takes place at elevated temperature, so you just keep on breaking the carbon and form all the possible nitro products. Not very important, but still giving you, not very important, but still giving you for those students who may feel, I've got this extra thing. So, but I'm telling you, not important, but yes, a line is written. Then sir, why you are giving? Because beta, a line is written in NCERT. Let me give you that line. See, although NCERT have not discussed anything about it, but just look at this line. That's why I say this is not a book from which you read. Yes, this is definitely a book from which you can have an revision that what is important and what is not. Now, why I'm saying it is important? Because see, one or more hydrogen atom of alkane can be replaced by halogen nitro group and sulfonic acid group. Then it is giving complete detail about halogenation, but it is discussing, see, in these just 2.5 lines, it is opening the gate for advanced that you can ask. See, I have told students that nitro group and sulfonic acid group can also be substituted with alkanes. I hope. सत्यम कुमार, सर मैंने 11th केमिस्ट्री नहीं पढ़ा, 12th में दिक्कत हो रही है. बेटा, this is what we are doing, my boy. Satyam, this is what we are doing. We are taking things very slowly, very properly, very effectively towards learning JEE through NCERT, learning class 12th through NCERT, but exploring all the options of class 11th together. So if I said that I'll be starting with alkyl halide, but see what is the title that I have given to today's class: hydrocarbon and alkyl halides. No matter I may take another, the next class that I'll be taking, I'll take few alkyl halide in that also. Why? Because complete organic is relatable. But I will finish first relevant things of class 11th linking to class 12th. This doesn't mean that we had a 2-hour class till this time. Haven't we studied anything about, sir? We have studied loads of things about class 12th. In fact, every reaction you will be needing in class 12th also. But if you do not read this and directly jump to NCERT of class 12th, then you'll always have a feeling, I don't know this, I don't know this. So technically you should start like this. So that is what we are doing, and this will definitely give you confidence. But yes, make these notes, write them properly, and then attempt questions around it. So Satyam, then everything will be good. Don't worry. Cool. Chalo. So I guess I have shown you. Now, moving forward. Now, if I move forward, I can definitely see, sir, first you can form all the possible nitro products. Now this is a detail that you get all possible nitro products. And over here, sir, technically, if you do sulfonation, then 3-degree hydrogens, because 3-degree hydrogen will form, is technically, you should just, for sulfonation, you should just know that 3-degree hydrogen is more reactive. That we will see why while discussing the radical. Obviously, you know, carbocation and radicals. If you are 3-degree, if you are the 3-degree carbocation or 3-degree radical, you are given more electron density, and that's why getting positivity or radical being electron deficient for a 3-degree carbon is not difficult. And that's why the reactivity of 3-degree carbon is more, and only for sulfonation, only this 3-degree hydrogen reacts with sulfonic acid. Obviously, the OH is OH of this, and H forms water, and it forms a sulfonic, it forms a sulfonic acid substituted compound. How, sir? So this is CH3, CH3. So remove OH from H2SO4. Sir, what is left? Remove OH minus. Sir, it will be HSO3, sir. HSO3. This is your sulfonic acid group which you have attached. So this becomes your bisulfate or sulfonic acid, not bisulfate actually, because bisulfate is HSO4 minus. This is sulfonic acid substituted alkane. And at what carbon it is substituted? At 3-degree carbon, because only 3-degree carbons are that much of reactive which can react with sulfonic acid. But sir, ultimately substitution taking place here also, less important, but still NCERT told, although not much of question has been asked, but still you should know. I hope everybody is clear. Now, chalo, moving forward, moving to the main and most important topic of substitution, which is halogenation. Now this you know from class 10th, alkane reacts with halogen in presence of sunlight or high temperature. Hydrogen gets substituted and you get your substituted product. Here I am explaining chlorination, so chloromethane. If you take halogen in excess, then sir, this substitution can take place multiple times. So you can have mono substituted, di substituted, tri substituted, tetra substituted. But yes, if you are taking methane in excess, or rather 1:1 mixture, then definitely mono substituted product becomes your major product, for which we have seen questions also from JEE Mains asking about the isomers. Now, next step is the mechanism. Again, this mechanism also is introduced to you from class 10. So just browsing through it. Chain initiation, radical formed because of sunlight or high temperature. Then after this free radical is formed, it will do chain propagation, as in it will end its chain, but this will also produce another radical. So hydrogen radical can also be produced, and in chain termination step also you can see the monochloro product is getting formed, or else this can even take hydrogen and can create methyl radical. So doesn't matter, this methyl radical or that H radical can continue to do the chain propagation, and in the end chain termination steps can also take place. So there can be multiple of steps. So again, like Wurtz reaction, this will also have a limitation, that here the percentage yield will not be very less, but yes, if in your exam you are asked the product, you should report the major product. What is that major product? Generally monochloro product, but percentage yield of this monochloro product will be less. Why? Because there will be possibility of many product formation. How? So this HNH can form H2 also, this methyl can form ethane also. Yes, here also you have a possibility of mono substituted products. So there, see, mono, that's why is more. Sir, you can have possibility of HCl formation also. And sir, even apart from this, let's say you have formed monochloro product. Let's say I have formed this monochloro product. What is it? Let's say I have formed this CH3Cl. In this chain propagation step, you can have this also. So let me exclude chain termination from this, that you can have chain propagation like this also. Like for example, you have your monochloro product. Let's say the concentration of this will get gradually, alkane will become monochloro substituted product. But sir, radicals are still available. So let's say if another radical comes and hit, so let's say if another radical comes and hit, it will remove hydrogen. What will be formed? Sir, CH2Cl and a newly formed radical here, because its hydrogen is removed by this Cl. So HCl will be released. Now this radical will try to do chain termination. If this guy does chain termination with another chlorine, then sir, dichloro. Similarly, trichloro, tetrachloro. So point is, if you take more of chlorine, so more of chlorine radical, so more of chlorine radical will have the possibility of getting di, tri, tetra, so on. So that's why mixture of product is largely produced if you take more of chlorine. If you take more of alkane, then you get your mono substituted product as your major product. Now some important points are why you have specifically taken Acha, we have some doubt, so let me first answer those doubt. By the time you guys, whoever is writing, can clearly write this, by the time I'm answering to some students. Sir, okay sir, thanks. Future doctor is asking, sir, I have a doubt. All NCERT of hydrocarbon are covered, sir. Sorry for interrupting. Hi, yes, beta. See, all as in for hydrocarbons, we will be dealing with that part which will be helping us to learn alkyl halides. What will be helping us to learn alkyl halides? Alkanes and alkenes, not alkyne and aromatic compounds, because aromatic we can obviously do with sir, with aryl halides. So yes, we will be learning alkanes and alkynes. I hope I'm clear. By the time you can ask if anybody has any query, else you can keep on writing this. Let me put quick, everyone. Thank you so much. Okay, future doctor. Superstar is always there. Clear. Chalo. Let us explore then. Sir, what will be reactivity, sir? Beta, reactivity, if you check F2, Cl2, Br2 and I2. Sir, why you have specifically taken chlorination and bromination? Because beta, F is very small bond length. Therefore, lone pair repulsion is very large. And because this lone pair repulsion, beta F2 is not reactive. F2 is very violently reactive, that it becomes hazardous to carry such reaction. So because F2 is very violent to react, so it becomes very difficult to control the product. And hence, because fluorination is very violent, so we avoid it. Similarly, sir, I bond length, because this is violent, so that means that will be least, and definitely it is. Although the reason, because obviously you will say, sir, bond can be broken easily, then why this? Because beta, whenever you form I radical quickly dimerize and form I2, because I radical has large affinity to form I2. That means, sir, I radical is not available for the attack, and that's why this iodination is not slow, it is very, very slow. So in order to industrially do such a slow step is financially and practically not viable. So yes, definitely chlorination and bromination, the intermediate steps are the famous halogenation reagents. So either you see chlorination happening or you see bromination happening, not otherwise chlorination or iodination. Now obviously, sir, we have seen this reaction is taking place in sunlight at a high temperature. Therefore, it is homolytic fission. We have already seen in the mechanism, sir. Sir, this also you have told regarding substitution that 3-degree electron deficient species as in carbon is stable. That's why 3-degree hydrogen will be most reactive, then 2-degree, and least will be 1-degree. This also I know, sir. Now, definitely, I know 3-degree hydrogen is more reactive than 2-degree and 1-degree, but with Cl2 and with Br2, what is the relative rate? Obviously, 3-degree hydrogen react with more speed with respect to 1-degree. But sir, chlorination will have different reactivity. Bromination will also have different reactivity with types of hydrogen. If we compare the reactivity of chlorination and bromination, again very important because very much loved by JEE, then taking reference, if with 1-degree hydrogen chlorination happens with a speed of 1 rupee, then with 2-degree hydrogen chlorination happens with a speed which is 3.8 times faster. So sir, this is chemical kinetics because we are talking of speed of reaction. Yes, so that means that this is this data is experimental data. Yes. So with chlorination, if 1-degree hydrogen is reacting with a speed of 1%, then with 2-degree hydrogen, chlorination happens with a 3.8 times greater speed, and with 2-degree, and with 3-degree hydrogen, it takes place with a speed of 5 times of 1-degree. So ratio becomes 5:3.8:1. Similarly, if you talk of bromination, ratio with 3-degree, 2-degree, 1-degree is 1600:82:1. A very important data which will help you to predict the percentage yield of product. How? We'll see that in example that I have written over here. Now, let us browse this through an example. Now, this is a question you have to tell the mono substituted products quick and the percentage yield. Can you do that? Definitely, sir, I can. How? How? Beta, as I've already made pictures that this carbon or this carbon, if you substitute with this chlorine, so name will be same, it will be 1-chloro. So if you are making this or this, product will be same. What will be the product? Sir, it will be 1-chloropropane. Either you add chlorine here or here. Now, the next possibility will be, sir, if you have 3 carbon and if you do that substitution here, so this will be 2-chloropropane. These are the two possibilities, sir. Now, which is major and which is minor? How will we estimate that, and how much is the percentage yield also? I want percentage also. Sir, easy, because you have given us experimental data, so we can calculate that yield. How? Beta, how many hydrogens are available who has a speed of reacting with chlorination to form this product? So these 3 and these 3 will be eager to get substituted and this will be formed. That means any of these 6 hydrogens will be replacing, getting substituted by this chlorine with speed of what? So 1-degree hydrogen they are. This is also 1-degree, this is also 1-degree. So this 1-degree hydrogen, sir, has a speed of 1 times. I'm calculating relative ratio, so that 1 become 1 times. How many hydrogen are participating with this 1 times of speed? So 6 hydrogens. So each hydrogen will be actually getting substituted. I'm not saying at the same time, but out of these 6, each will be having an affinity of getting substituted with a speed of 1 rupee. But how many are capable of earning this 1 rupee? So 6 members. So total is 6%. How? amount of product produced is equal to the relative rate, which is 1 times, into number of hydrogen of that particular type. So how many hydrogens can be, sir, although this is also 1 degree, this is also 1 degree, but any of these 6 if replaced, I will be getting this product. So how many hydrogens you have as that possibility? 6, sir. What about this guy? This guy is just having 2 of those hydrogens. So how many, what is the number of hydrogens? 2. But each hydrogen will be reacting with what speed? Sir, 3.8 times. So this is 3.8 times of 2. That means, sir, 7 2 is 14. So this is 0.4 less. That means 13.6 times. So can you calculate the percentage? Yes, sir. Total yield is 6 plus 13.6. So percentage of B will be 13.6 upon total into 100. Percentage of this will be 6 upon total into 100. Now I'm definitely, you do not have to do that calculation, but if you have to, then definitely for good level of questions you have to do this calculation, which will definitely tell you that this is your major product because forming in more percentage, and this becomes your minor product. I hope everybody is with me on this. Okay, thank you, Goat. AI can't replace me. Okay, beta. Thank you. Thank you so much. Okay, chalo, perfect. Moving forward. Now, sir, next. Some question. So try and attempt this one also. Try and attempt this one also. Quick. Try and attempt this one also quick. The question says, number of bromo derivatives obtained on treating ethane with excess of Br2 in diffused sunlight. So if I have ethane with excess of Br2 in diffused sunlight, okay, bromo derivative. So beta, it is not restricting that it should be 1 degree, it should be mono, di, tri, tetra. No, it is not putting a cap to anything. This is also JEE 2023 question, an integer type question. So obviously I have given you the answer 9, but you have to predict how 9. You have to give the bromo derivatives obtained on treating ethane with excess of Br2 in diffuse sunlight. So you just have to talk about bromination, but all possible isomers. So let us do it, sir. Ethane, sir. So that means this is my ethane. Let us first talk about the mono substituted products. Sir, just add bromine here or here. Anywhere, this will be the only possibility. So structure number 1. Now, second, sir, this you have already formed. Now you can decorate this with what? Bromine. So if I am trying to decorate this, I can add bromine where? Sir, you can add bromine here or there. That means I can have bromine here or here. Do I have any more possibility of dibromo derivative? No, sir. That means this is also fixed. So how many of them I have? 3. Now if I try to do tribromo derivative, so this can also be, so I can have 1 bromine here or I can have 1 bromine here. So this can become a tribromo derivative. So let us first pick this and beautify this with bromine. I can have 1 bromine here and 1 bromine there. That means, sir, 1 bromine can be added here also, 1 can be added here also. So this is the 2 possibilities from this carbon. Now, so this is my 4th possibility, this is my 5th possibility. Now let us do possibility of this. Substituting here the tribromo derivative. So 2 bromine on one side and 1 bromine on the other side. 2 bromine on one side, 1 bromine on the other side. If I add 1 here, sir, it will be same. So no, sir, no possibility because it is already done. So if I cannot add here, let us try here. So 1 bromine, sir, 2 bromine on 1 bromine. So sir, don't make it, sir, because it is already done. So I hope how many possibilities I am left with, sir? 5. But sir, you have to go more because it is not giving a cap on number of bromine that you have to. It is telling you number of bromo derivatives. So I have to think of all possible derivatives now, sir. So di is done, but sir, now you have to work on them. So let us first take this, because obviously with this I can have only 1 possibility. Acha, I have not duplicated it. Huh. So let us work on this possibility. So this will be sixth structure where if I add one bromine here, it will be tetra. There are no other options. Now I have to work on this tribromo derivative. So if this tribromo derivative is added, so sir, here you have already added, you just have possibility of adding here. So it will also become tetra. Sir, but then 3 and 1, then 3 and 1, that means sir, you do not have an option because it will be same. So cancel this. Now that means I just have one possibility left. Now sir, what else? Acha, if I add here beta, I guess bromine. This is tetra, na? No, beta. I'm sorry. If I add one bromine here, it will be 2, 2 because it is having 4, 3, 1. It will be 2, 2. Okay, I'm sorry. But yes, beta, a question where you have to work. So this will give you the seventh one. So ultimately, I have 2. I have 2 possibility of tetra. Then again, sir, after 4, add 5. So here I can add 5 here. So this will be 3, 2. And what about here? Here, if I add here, it will be 3, 2. Here it will be 3, 2. So that will be the same. So I will have only one possibility, that if I use this and I add bromine, it will be my 8th possibility, and obviously 9th possibility will be all bromines. So how many possibilities I have? 9. Yes, somebody can even do this in mind with practice. I'm not saying that, but because I am treating this as a beginner's class, because I'm treating everybody starting fresh, and I do not, so that's why I have written properly. I hope I am clear with this. Sir, okay. Because every H in ethane is equivalent, excess sunlight have. Yes. Definitely good. Perfect. Moving forward. Now, sir, next question. You have to give what, sir? Number of alkanes obtained on electrolysis of a mixture of sodium salt of acetic acid and sodium salt of that is ethanoic acid. This is propanoic acid. Sir, we definitely know you are doing electrolysis. That means that CO2 will be released. And sir, this is not soda lime, so no carbon ion, sir. This is radical, sir. So one radical will be CH3 radical and one radical will be C2H5 radical. So this is one radical. This is another radical. How many products I can have? So radical can have chain termination. So either I can have CH3 bond CH3 as an ethane, either I can have ethyl, or I can have cross, which will be actually major product because percentage of this and this will be more, so their termination will be more probable. So that means CH3, CH2, CH3. So how many possible products? 1, 2, 3. It is asking us the possible products. So how many possible products? I have 3. I'm already giving you the answer. I want you to have a clear-cut logical idea around it. I hope I am making myself clear, guys. Chalo. Moving forward. Great. Sir, you said iodination cannot take place. Yes. But can I experimentally force? Can I watch this lecture for my boards? Yes, beta, definitely, because we are doing NCERT. So definitely you can do this for your boards as well. Clearly you can do these for your boards as well. Chalo. Now, definitely it will be helping you like anything. Chalo, quick. Sir, what else? Sir, you said that chlorination and bromination is possible. Fluorination can't be done and iodination can't be done because fluorination is violent and iodination is very slow. Can I have some experimental apparatus where I can force iodination to take place? Yes, I can. How? Beta, think of Le Chatelier principle. We said that alkane on reaction with iodination is highly reversible reaction. It is not at all going forward. It is highly reversible. Why? Because it can definitely form this and this, but the moment this is formed, this reaction is highly reversible because iodine radical will again meet with iodine radical and not meet ethyl radical. So reaction will not proceed in forward direction. But sir, even reaction is not at all proceeding in forward direction, it will definitely have some very negligible value of K. So let's say out of those 1 crore molecule, only one molecule is reacting. Agreed. but ultimately at equilibrium I need 1 1. Okay. If I again apply Lee-Chatelier principle, and as per Lee-Chatelier principle, if I remove if I in if I remove this product, if I remove the product and on the same side I add a reactant, then it will try to oppose and reaction will be proceeding in forward direction as per Lee-Chatelier principle. So if you use some oxidizing agents like HiO3, HGO, mercuric oxide, nitric acid, what they will do, sir, they are very strong oxidizing agent and they can oxidize Hi to I2. Technically, it is the third one is not creating I2. Again, a very good advanced inorganic fact, because mercuric oxide reacts with Hi, iodine is taken away, but it is precipitated in form of HgI2. So here, this product, this reactant is not produced, but ultimately this product is removed. So this will force the equilibrium to shift in forward direction as per Lee-Chatelier principle. I hope everybody is clear. Now, moving forward. So then comes is combustion. What does combustion mean? Beta, first thing that combustion mean is reaction with oxygen. So if you have alkane and you try to react this alkane with oxygen, you are going to produce CO2 and H2 and large amount of heat. You are going to produce CO2, H2 and large amount of heat. So that is simple combustion. If you take less of oxygen, sir, it will be incomplete combustion. All these are NCERT details, beta. Less of oxygen. If you use less of or limited oxygen, you will get unburned carbon. So this unburned carbon can also be used in carbon ink, in your laser printers, wherever you have that ink, your newspapers. So definitely again a useful reaction, that is incomplete combustion. But what is combustion, sir? Combustion is making carbon release as CO2, hydrogen is released at H2O, but sir, combustion is actually complete oxidation. So if I get some way of doing partial oxidation, I can have intermediate products. Now, in order to learn that, understand that, first let us understand this, that if I have alkane, that means I have all carbons attached with hydrogen. If I do oxidation of just one C bond H, I will be getting, replace one C bond H by OH, so I'll be getting the corresponding alcohol. That is the first step, oxidized product. If I oxidize this alcohol, if I try and oxidize this alcohol, then this alcohol will become, sir, C, 2H are there, one OH and another OH. What is it, sir? Sir, it is, if you have two OH on the same carbon, OH's functional group is called all, and whenever you have two functional group on the same carbon, that is called a geminal position. So this is a gem diol, and technically gem diols are highly unstable. Why? Because two electronegative atom attached with this carbon will make this carbon go mad, and hence to stabilize this diol, dehydrate. So with release of water, what you have obtained, so CH2 is obviously here only, but this guy, this oxygen is still here, which will be double bonded oxygen. So if you simply write this, this is nothing but aldehyde. So now picture is getting clear, sir, that alkane, the first step oxidized product is alcohol. The second step oxidized product is a carbonyl compound. Depending upon the carbons that are attached to this carbon, it can either be aldehyde, it can either be ketone. That means we are learning ketones also. We are learning alcohols also. And once aldehyde is further getting oxidized, so one step as in replace one H by OH. So you can obviously see now, one is definitely double bond O. If you replace this one H by OH, sir, it is nothing but carboxylic acid, sir. So that means if you just control this combustion, you can have n number of products, and ultimately the last oxidized product will be the burnt carbon. As in, once you aag laga diya, once you have burnt this acid, so last H will be replaced by OH. So last step oxidized product will be, so this was already OH. This last hydrogen has also transformed to OH. So this is again the same thing. One carbon having two OH is unstable, gem diol, sir. So in order to stabilize, it will also release water, but now I'm writing that water. Why? See, H2O, and ultimately CO2. Sir, this is combustion, sir, because combustion of alkanes gives CO2 and H2O. I hope everybody is clear with me. Hello. Hello. Cool. So if I have some reagents which can stop my oxidation of alkane at any step, then sir, this will be industrially a breakthrough. And such breakthroughs are given in your NCERT. The same reactions. Alkane once reacted with molybdenum oxide, it forms aldehyde, the second step oxidized product. Alkanes once reacted with copper but elevated temperature and pressure, because NCERT facts, so learn it, 250 degrees Celsius and 100 atm pressure. It creates the first step oxidized product, alcohol. Technically, higher alkanes are converted to acids, because higher alkanes acids are industrially very useful in formation of your soaps and detergents. So higher alkanes like 16 carbon chain is getting oxidized using manganese diacetate to corresponding carboxylic acid, and because it is long carbon chain acids, also termed as fatty acid. Last, the oxidizing agent which you have seen in your class 9th and 10th, which is KMnO4, K2Cr27, they can also be used. Technically, KMnO4 in alkaline medium is NCERT says a very famous beta. Every reaction has been asked by JEE. A clear-cut NCERT page. Now, sir, what is this? This is an isobutane. That means, sir, only 3 degree. Just like sulfonic acid, only 3 degree hydrogen, because they are very reactive, but not all alkane. But all alkanes having 3 degree hydrogen, only they can be oxidized. That means they can be substituted with OH. So a very famous line to line NCERT reactions. I hope everybody is with me on this. Moving to the next reaction of alkanes, which is isomerization. A very famous reagent, anhydrous AlCl3 in presence of HCl. Direct questions are asked how to make isomers. Whatever carbon chain you have, just subtract one carbon. So if I have hexane, subtract one carbon, how many carbon you will be getting? Sir, 5. So draw those 5 carbons. Now, whatever possibilities you can think, make those possibilities. So if I have this 5 carbon, I can have one branch here, one branch here. So sir, whatever, only 2 possibilities, sir. So I can add 1 chlorine here. This will be 2 chloropentane and this will be 3 chloropentane. If I add here, this will again be 2 chloro, because I'll be numbering from this side. So what is isomerization? Using anhydrous AlCl3 in acidic medium, you can, whatever number of carbon atoms you have, you break one carbon and draw all possible isomers. Those will be your mixture of products, and such process is called isomerization of alkanes. Moving forward, now, what is aromatization of alkanes? It's the same. You first have to know the reagents. What are the reagents? The reagents are, you have to use either any D block metal oxide, not every, but yes, precisely, chromium oxide, Cr2O3, vanadium oxide, V2O5, molybdenum oxide, MO2O3, elevated temperature of 500 degrees Celsius and elevated pressure of 10 to 20 atmospheric pressure will do what? Will remove hydrogen. But if I remove hydrogen from, if I need to create an aromatic compound, then definitely you should know that cycloalkanes having 6 carbon chain is free from any type of Bayer strain. That's why only generally what rings you get as aromatic rings, benzene as in 6-membered ring, because it is not having any level of strain. So if you remove hydrogen, so then first cyclization will take place. So let us form the cyclic structure. So remember, one hydrogen here, one hydrogen. So if I remove just 1 mole of hydrogen, so 1 H here, 1 H here, ultimately I am going to produce cyclohexane. But if I now remove 3 moles of hydrogen, so further 3 moles of hydrogen, as in 1 hydrogen, this will lose, 1 hydrogen, this will lose. If they will lose 1 hydrogen, in order to satisfy the valency, they will have 1 double bond. If this guy and this guy loses hydrogen, I will get another double bond. If this guy and this guy loses hydrogen, I will get another. So 3 moles of hydrogen. Sir, now you have created your aromatic benzene ring. Now, sir, if I have heptane as in 7-member carbon chain, again, first cyclization, but what cyclic ring will be most preferred? Sir, six member. Why? Because free from any strain. So if I am allowed to form a product, I will try to become that product which will be most stable. So even if I use 7-member carbon chain, but I will love to form 6-member ring, yes, one will be acting as a branch. And after that, if I remove, let's say I am removing 4 moles of hydrogen in first step, so first step will do cyclization, and the next step will further remove 3 moles of hydrogen, creating benzene ring. So this will be nothing but toluene. Very famous reactions, beta. Very famous reactions of NCERT. Hence NCERT. I'm again and again telling you. I hope everybody's clear. Now, moving to the last reaction of alkanes. So last reaction of alkanes is nothing but pyrolysis. Now, what is this pyrolysis? If you kick me from the 16th floor of a building, yes, very violent example, but still best example to explain the product. If you kick me from the 16th floor of any building, what will happen to me? The priority is the most common thing is I will die. But I will die how? Maybe on day one, when let's say I can die multiple times. I am Super Mario, I have multiple lives. The first day you have kicked me from 16th floor, I have fallen on my head, heard bested. Definitely pyrolysis as in cracking is happening, but how? So depends on the day. On the another day, if you throw me, if you kick me, maybe I can fall, because sir, the number of rolls I will be taking will be random. Now why I am giving this example is because beta pyrolysis is also thermal cracking. So if you apply that extensive heat, definitely compound will crack, but what product it will be forming after cracking will be variable. Hence you can have variety of products. Definitely this also we do to large number of carbon bearing alkanes, or starting with hexane, NCERT fact. If I burn this hexane at 500 degrees Celsius, definitely bonds are going to break, as in sir at high temperature homolysis. So first possibility of homolysis is remove one H, one H. So remove one hydrogen, so self chain termination, so alkene can be formed, although very less possibility because carbon will also break. Next, sir, you can form butene and ethane. See, molecular formula will also getting satisfied. You can either form propene, ethene, or methane. So ultimately pyrolysis is cracking, as in carbon forming mixture of alkanes and alkenes on cracking. Now why this is very important? Because there is a 12-member carbon chain, a very basic reaction but a very industrially important one. This is nothing but this is dodecane, which is a major component of kerosene oil. So whenever kerosene oil is undergone a high temperature of 700 degrees Celsius under catalyst like nickel, platinum, palladium, that guy will also crack. But why I'm using specific temperature and specific catalyst? Because I've industrially mastered this reaction. I can control how you will break. Not exactly, but yes, large fraction will be controlled, and mixture of heptane and pentene are majorly produced. This mixture is nothing but beta, it is called petrol gas. So that is how you take crude oil and you crack that crude oil to form petrol and diesel, which definitely requires fractionating columns, which can do this application of catalyst and temperature, and can form your product, which is obviously done in the refineries. So again, a very important industrial reaction, where last being, sir, methane can react with steam also, producing a very famous inorganic gas called syngas or water gas or synthesis gas, because mixture of CO and H2 created at around 1000 degrees Celsius with nickel solid as catalyst is again an example of zero order kinetics, because all the reactions which have solid catalyzed gas transforming and forming product are following actually zero order chemical kinetics. So this water gas, this syngas, is actually used to create many other compounds, and hence it is also termed as synthesis gas, because it is used to synthesize many compounds. I hope everybody is clear. I hope everybody is clear. Chalo, moving forward. Again, a basic question which I have already given you with the text. Let us just read the question, because definitely you should know mains, after advanced mains has also started doing it, they have merged chapters. So hydrocarbon logic, applying mole concept rule. How a hydrocarbon A undergoes combustion in presence of air, it requires 9.5 milli equivalent of oxygen and produces 3 equivalent of water. So I've just written the reaction because a very probable question for your JEE. If you just balance this, you know number of gram equivalent. Sir, if you know number of gram equivalent, that means you can directly relate with the stoichiometric coefficients. So instead of this, you can have how much of oxygen it is requiring, 9.5. So this is nothing but 9.5. How many gram equivalents of water is produced? 3. So y by 2 is nothing but 3. So that means y is 6. If I put y as 6, I will be getting x as 8. So clearly, these type of question comes where you have to know the organic reaction and you apply your stoichiometry. Now, what else, sir? Acha, this is done. Okay, beta. With this we have finished alkanes. Now I guess I will be doing one thing. I will be merging alkenes with, I will be trying to merge alkenes with alkyl halides. Okay, because I wish to complete alkyl halides in this class. But yes, merging it with alkenes will rather benefit. So I will merge alkenes with alkyl halides and I'll be coming back. Let us take a dinner break for 15 minutes and we'll be again meeting at around 11. Is it good? I want everybody to come back though. Okay, chalo. So whoever is studying, because I know many of you will be, so let us take a 15 minutes break and then we'll come back. So we will be meeting again. We will be meeting again at, this is 10, no? So we will be again meeting at 11 p.m. Cool? Chalo. So bye bye. But come back. We'll be back by 11. Okay. Yes, guys, I'm back. Sorry for the 4 minute delay. So, who all are there with us? Just give a confirmation. I'm clearly visible and audible, guys. So Superstar is already here. Then we have Ashish Prajapati. ये तो सिर्फ okay. Then we have Sparsh. Then we have Rakshit. Chalo. So guys, let's start. Chalo. Perfect. Let's start. Now. Perfect, superstar. Perfect. Now, sir, what else, sir? Beta, now we will be coupling the chapter of alkenes with alkyl halides. Now, why? You will have an idea. Now, why I have told in the beginning only that you should always have a start as per logical conception. Now, let us first come to NCERT. NCERT alkyl halides. Now, sir, in alkyl halides, what we have to read, sir, the initial things as in the IUPAC, the isomerism involved, and the physical properties. Those you can very well judge with the common sense of alkanes that we have acquired. Now, obviously, we'll do some classifications because their general naming, their classifications, these all NCERT facts we'll be doing. Post that, nomenclature, and then the isomerism shown, which we have already practiced. Then we'll be discussing why alkanes are paraffin. But alkyl halides are, so they are reactive because alkanes have no polarity. Alkyl halides, on the other hand, has this polarity of delta positivity and delta negativity. Hence, the reactions of alkyl halides are very probable and they have more affinity for those substitution by a nucleophilic reactions, and therefore they have high weightage also in your JEE examination. Then, sir, after that, we'll come to preparations. So, alkyl halides can be prepared from alcohols. Alkyl halides can be prepared from hydrocarbons. So those alkane things that we have done will come into picture. Now, they can also be prepared for alkene. So we will be just including that area of alkene which will be producing alkyl halides. So I said I'll be making alkenes. So all the alkenes which pertain to alcohol, that we'll discuss in the chapter of alcohols, but all the reactions of alkene pertaining to preparation of various type of alkyl halides, that we have to do. Although in NCERT only this much paragraph is written, but obviously this gives a click and direct relationship with alkenes to alkyl halides. So that's why we'll be doing alkyl halides, alkenes also along with alkyl halide. And last preparation of alkyl halide is by halogen exchange, because we produce chlorobenzene and bromobenzene so easily, and rather fluorobenzene and iodobenzene are very difficult. One of the student was saying in at the initial, sir, I forget Finkelstein and Swarts. So Finkelstein has a factor of I, the name Finkel in I, so it is required to produce alkyl iodides, and Swarts reaction is required to produce alkyl fluorides using halogen only. So the last method of preparation is halogen exchange. Then we'll do some preparations for aryl halides. That is definitely from the chapter of benzene and its compounds. So that part of aromatic hydrocarbons also will be included in the chapter of alkyl halides. And the most famous is Sandmeyer's reaction. So see, Sandmeyer's reaction, NCERT has invested more than 50% of the page, so that also makes it important. And last will be, after physical properties, last will be chemical properties. So chemical properties of alkyl halides are basically three: the substitution nucleophilic, the elimination reaction, which we can definitely understand because all the elimination reaction of alkyl halide will produce alkene. So that means that again alkene will come into picture. And last will be reaction with metals, and we will be finishing with the last 2 pages of NCERT, which is regarding the polyhalogen compounds. So task is big, but because we have done alkanes, and we will be specifically and subjectively and conceptually doing the areas of alkene which will be helping us to understand alkyl halides better, that will make the process more productive. Okay, chalo. So I guess now you have an idea of NCERT. So with the idea of NCERT, let us first explore the area of alkenes. So the first area of alkene, which is quite relevant for the preparation of for the chapter of alkyl halide, is preparation of alkenes, because how you are preparing this alkene with alkyl halides, so this they become the reactions of alkyl halides. Now, because preparation of alkene can be done by dehydrohalogenation, which is nothing but beta elimination, also termed as E2 elimination of what? Of sir alkyl halides. Now let's say I have this alkyl halide. Why I say beta elimination? Because the carbon next to the carbon which is connected, through which this functional group is connected, is called the alpha carbon. The carbon next to this functional group becomes your beta carbon. So alpha carbon X and beta carbon H is released, but how? You need a very strong base, and that strong base is an alkoxide ion produced by alcoholic KOH. This alcoholic KOH can be written in any of the ways. Ultimately, it is giving you RO minus, which is acting as a very strong base. Now this strong base gives electron to hydrogen. The moment hydrogen has received electron, hydrogen do not require this electron, which is asked by this carbon, which is demanded by this carbon, because this carbon is attached with a electronegative species, which is halogen. Halogen is very much willing to snatch this electron of carbon, but this carbon should get a supply of electron, which is given by the beta placed hydrogen. So this hydrogen loses electron. So ultimately what you are going to produce, so these two carbons are as it is, the tetrahedral carbon. But now because one sigma bond has turned into a pi bond for both of them, so this electron it has received from hydrogen, this electron was of this carbon only. So this sigma bonded hydrogen has concluded to a pi bond, and that's why the tetrahedral alkane has turned into a trigonal planar alkene. So what will be the byproduct? This RO minus with H will form ROH, or whatever base with H will form B and H, and this X is released in form of X minus, making it a very good leaving group, because this leaving group is good because bond length is high. Why bond length is high? Because I have taken chlorine, bromine and iodine. That means sir, fluorobenzene do not undergo elimination. Fluoroalkane, alkyl fluorides do not undergo elimination. They do, but the mechanism is different. This is your basic E2 mechanism or beta elimination. Sir, why it is termed as E2 mechanism? Let us explore that side also. Now, why it is termed E2 mechanism? It is termed as E2 mechanism because of the fact, if you just check the mechanism, sir, the mechanism was just having single step. So the mechanism is just having single step. Sir, the molecularity, what is the number of reactant molecules? 2. Hence the name 2, because elimination is happening and the number of reactant molecules are 2. That means the name that is given to this mechanism is elimination bimolecular. What will be the order of the action, sir? It can only be determined through experiment. So we have done that experiment and calculated the rate of reaction, which came out to be directly proportional to concentration of alkyl halides raised to the power 1. So the more you use alkyl halide, the more becomes the rate of reaction, and the concentration of the base that you have used. More is the base, more is the mechanism. So molecularity is also 2 and order is also 2. Now, one important point is, as you have seen in the picture also, that I have deliberately used that hydrogen which is placed exactly opposite. Obviously, this is not a symmetrical system. I mean, yes, this is not a 90-degree angle. This is a tetrahedral system. So the hydrogen that is farthest from halogen is removed. This is called NT. Remember in the initial class somebody was saying, sir, what is syn and what is NT? So syn as in from same side and NT is from exactly opposite side. Now sir, why exactly opposite? Beta exactly opposite. Beta exactly opposite because of the fact that base is also electron rich, halogen is also electron rich. Sir, minus minus will repel each other. That means base has to approach from that area which is farthest from this electron rich halogen species. I hope everybody is clear. I hope everybody is clear now. So that means this hydrogen will always be that hydrogen which is present in NT position. Now in organic chemistry, or in rather the whole of chemistry, this word we use very often. This word we use very rarely, not often. Always in chemistry is a very tight word, but I'm using that tight word over here because obviously the whenever you are doing any beta elimination, the hydrogen has to be the oppositely placed hydrogen irrespective of everything, because the reason I've already communicated, minus minus repel each other. Now this reaction is highly stereoselective and stereospecific both. What does that mean, sir? Beta, are you very much attentive and are you very much vigilant that what hydrogen has to be used? Yes, sir. And you are vigilant about what, sir? About the stereochemistry of the reactant. I definitely want that hydrogen which is opposite. So you are being highly specific about the reactant, that this reactant, that side I will use, this side I will not use. So if you are specific in the stereochemistry of the reactant, then such reactions are called stereospecific reactions. So wherever specific word comes, you should always remember it is reactant specific. Now what product you will be producing? Sir, I will be producing alkene. Sir, if more than one beta carbon is present, then what alkene you will be forming? Sir, I will be forming more stable alkene. That's why you are specific about the product also. Rather, don't use the word specific, because such reactions are called stereoselective. When you are picking that this product I will form and this product I will not form because of XYZ reason. So if you are specific about the product also, such reactions are called stereoselective reactions. So with selective, you should remember the word product. With specific, you should remember the word reactant. I hope everybody is clear now. What can you say about the leaving group ability, sir? More be the bond length, easily I can be removed. So iodine will be the best leaving group, followed by less than that will be bromine, less than that will be chlorine. That's why for E2 elimination I have not even written fluorine, because C bond F is very small, because both are second period elements. Bond rather cannot be broken that easily. I hope everybody is clear now. Moving forward, chalo, moving forward, reactivity of degree of alkyl halides. Sir, ultimately what type of alkene you are going to produce? Remember, during the preparation of alkanes, the first reaction was with alkyl halides, when we used lithium aluminium hydride with a 3-degree alkyl halide. Instead of a reduction, elimination was taking place because product was very stable. So you can obviously have an idea with that. That's why, because H minus can also act as a base if product is a stable alkene. So which alkyl halide will be most reactive, sir? 3-degree. Less than that, 2-degree, and least will be 1-degree. Why? Because 1-degree will be forming very relatively less stable alkene, because it will be not much substituted. Now, next point that I have already communicated while discussing the stereoselective nature, that if you have more than one beta carbon, then whose beta carbon hydrogen will be removed to form alkene? Sir, the beta carbon which will be giving you more substituted product. This was initially given through GOC, we understand that, but it was actually given by a scientist also, and therefore this is also called Saytzeff rule or Saytzeff rule, and the product is also called Saytzeff product or Saytzeff product, which says you should always form a more stable alkene. And in order to form a more stable alkene, generally which beta carbon is removed with its hydrogen, which is already having less hydrogen. Why? Because if I have less hydrogen, then the probability of me having more alkyl substitutions will be good. But rather, you should just know that this is Saytzeff product. What does it mean? Although you should always make the product with your common sense of GOC, that the alkene which is having more hyperconjugating hydrogens is more stable. I hope everybody is clear now. Perfect. Let us do what we have learned with an example, a very famous and a very basic example rather. If I have butane and this butane is substituted with bromine at second position, then with this alcoholic KOH, what can I do? Sir, with this alcoholic KOH, what you can do is this base will come, but here, sir, as you have already discussed, you have two beta carbon, this beta left and this beta right. If I remove hydrogen of this beta carbon, which will be having three hydrogens, sir, alkene will be this. Alkene will be minor alkene. Why you are saying minor, sir? Because beta, you can obviously calculate the hyperconjugating hydrogens, which we'll be doing. But if I remove beta hydrogen of this carbon, the alkene that I will be getting will be this. So let us calculate. Okay, I'm sorry, there is no methyl group. This is bromine, so this bromine gone, double bond can come here, double bond can come here. Now why I'm saying this is major? Just calculate number of hydrogens of the carbon, sp3 hybridized carbon attached to alkene. So this carbon has 3 hydrogen, this carbon has 3 hydrogen, so hyperconjugating hydrogen is 6. This has no sp3 hybridized carbon, only this alkene has. This has only 2 hyperconjugating hydrogens. So obviously this is more stable, hence this is A, this is less stable, hence this is B. You should always calculate hyperconjugating hydrogens rather. Perfect, Neha. Perfect, Neha. So this is but2ene, which is major product, that is but1ene, the minor product. Perfect, beta. Chalo. Moving forward. Now, sir, then what about alkyl fluoride, sir? Because we are learning alkyl halides with alkenes, so tell us about alkyl fluorides also. Okay, with mechanism. Okay, sir. Let's say I have 2 fluorobenzene using alcoholic KOH. Now, sir, again, base is a strong base because alcoholic KOH is giving RO minus, which is rather a very strong base than hydroxide ion. Okay, sir. So I can form this alkene also and this alkene also. But sir, you have already written the product which is actually less substituted product. But when less substituted product, as in less stable alkene, is produced in larger percentage, then this is what Saytzeff has not said. So but it is produced. So somebody must have done this experimentally, and hence these products are called Hoffman products. When less substituted or less stable alkene is actually produced in larger percentage, that is, they become the major product. Such products was estimated and quantified to the science community, to the chemistry community, by the scientist called Hoffman, and therefore these products are Hoffman product. Now, sir, why it is happening? Let us browse through the steps. As I've already communicated, sir, C bond F is very small. So if C bond F bond length is very small, then sir, bond will be very strong. Then why the hell this bond will break? I definitely know this will not break. But sir, base is already present. So base will come and give electron to beta carbon's hydrogen. Yes. So if this beta carbon hydrogen base is given electron, minus will come here. So 1 degree carbon ion. If here, then 2 degree carbon ion. That means that carbon ion is formed. Yes, because beta, it is not agreeing to go. That means what will be formed first? Carbon ion. 1 degree or 2 degree? Sir, carbon ion is electron rich, sir. Don't give more electrons. So actually 1 degree carbon ion will be formed, and hence this carbon's hydrogen will be given electron, and hydrogen electron will be taken by this carbon. And hence what will be formed, sir? Beta, a beautiful carb anion. And now you can logically think also that this carbon ion will be more stable as compared to this 2 degree. So whether it should be formed or not, definitely yes, sir. This is my first step, which rather chemical kinetics suggests that the rate with which carbon ion is forming is really fast. Now what happens in the second step, sir? Common sense, beta. Because this carbon ion is now formed, although I definitely agree, although fluorine is a second period element not willing to leave. But if somebody is offering their electron, then ultimately this electronegative guy will leave one day. Yes, chemical kinetics suggest that this reaction is very, very slow. Hence, this becomes your rate determining step of chemical kinetics. And because this step is very, very slow, but ultimately once this is going to happen, what alkene I am producing? Sir, I am producing a less substituted alkene, but this is conceptually correct, sir. Hence produced in more amount, sir. This mechanism is therefore termed as E1CB as an elimination unimolecular by this conjugate base. Why? Because beta, generally molecularity we define for the slowest step, although molecularity is defined for each step. So this slowest step has how many species as reactant? One, sir. So molecularity of this reaction is definitely one. Steps involved are two steps. Step 1, step 2. Now, is this carb anion your reactant? No, sir. I have brought from market alkyl halide and base. I have not brought this carb anion. This is a reaction intermediate, sir. So how can I replace this reaction intermediate from step 1? Because obviously all reactions are equilibrium reactions. So experimentally I can calculate the value of equilibrium constant K. If I calculate this equilibrium constant K, it will be nothing but carb anion concentration upon alkyl fluoride concentration upon conjugate base concentration, the RO minus. But I have carb anion as my rate determining step. So rate of the reaction will be written as carb anion concentration raised to the power 1. But sir, this is not my reactant. So because it's a proportionality, so I can replace this carbon ion with K, sir, constant. So proportionality may it will be gone. So alkyl fluoride and conjugate base. So instead of this carbon ion, I will be having alkyl fluoride concentration into conjugate base concentration. So now you tell me what is the order of the reaction? Sir, order of the reaction is reactant concentration power summation, that is 1 plus 1. So beta, order of the reaction is 2, molecularity is 1, step is 2, and because molecularity is 1, that's why it is called elimination unimolecular by a conjugate base. I hope everybody is clear with this. Moving to sir, then all the time you can only form Saytzeff product? No, sir. Nahi beta, molecularity is 1, order is 2. Neha, molecularity is 1. Why? Because in rate determining step, how many reactant species I have? 1. But order is 2 because order is power of concentration terms of reactant. Is carbon ion your reactant? No, sir. Are you adding carbon ion? No. So can you control the concentration of carbon ion? You can control the concentration of reactant that you're putting. So rate is definitely proportional to carbon ion concentration, but then you have to replace carbon ion. Okay, because Neha was writing, so beta, Neha, you are superstar. Your doubt is everything for us, for me technically. Chalo. Now, sir, then do we have any other case when we get less substituted product as major product? Yes. Again, a part of alkyl halide and very much loved by JEE. What is that? Case 1 is when you have bulky base. Sir, base will give electron to hydrogen. But if base is very bulky, then it can't enter the carbon which is crowded. It can only prefer to enter and give electron to that carbon which is least hindered. Now you tell me, if this is my alkyl halide, if this is my bulky base, then this bulky base will give electron to this hydrogen? No, sir. This is quite hindered from both sides, sir. So definitely it will try to give electron to hydrogen of this carbon, which will be just outside. So it will give electron. The moment giving electron, it will come here. Bromine will leave. I hope you're getting it. But sir, you are entering from the same side, beta. This is tetrahedral. Obviously, it will also be happening on of the opposite hydrogen. This is tetrahedral, so that doesn't make sense in stereochemistry because we are writing the 2D structure. Now, that means that again opposite, but opposite to of that carbon which is least hindered. So here also, what alkene you are going to form? Sir, here also I am going to form this alkene and this alkene, sir. If I would have formed that alkene, it will be more stable, but this will be your major product. And because this is less substituted, so called as Hoffman product. I hope everybody is clear. Moving to the next case. Whenever you have conjugated system, then also you do not get Saytzeff product, you get Hoffman product. Why? Let's say I have hexene, hex as in 6 carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Now let us decorate this hexene Ene is nothing, position is not mentioned, so 1, 2. At fifth position, I have a methyl group. At fourth position, I have an iodo. So this is my 4-iodo 5-methyl hexene. Okay, sir. Now, if it is subjected to alcoholic cuvette, sir, it is already having a double bond, sir. So how many beta carbon possibility I have here? Sir, again, this is halogen, sir. This is also beta, sir. This is also beta. So if I remove hydrogen of this beta carbon, what I am going to get? Sir, if you remove halogen of this beta, or rather, let me just take this. Huh. So if I remove halogen of this third carbon, I will be getting hydrogen of this carbon and I. So with this HI removal, I will be getting this alkene. With fifth carbon, if I'll be doing, I will be getting this alkene. Now, so technically this is more substituted, more hyperconjugation, but beta, as per GOC, what is more strong electron displacement effect, which is more stabilizing effect? So sigma pi conjugation or pi pi conjugation? Pi pi. Resonance is a more dominating and strong stabilizing effect than hyperconjugation, and I hope you can now see. So this is pi sigma pi. This is a conjugated alkene, sir. So technically this should be my major product and this should be my minor product, but because, sir, again Saytzeff rule is violated, the product which is less substituted is major product, hence this is also termed as Hoffman product. I hope everybody is clear. Next, sir, beta, if Saytzeff product is also not formed if the product is sterically hindered. I mean, not product, actually it should be reactant. It should be reactant. When Saytzeff, okay, huh, if the produced Saytzeff product produced, you can think of with reactant also. So let's say I again have RO minus. Although this base is not bulky, if I remove hydrogen of, if I remove this beta hydrogen, this one, then definitely beta I'll get a substituted alkene. But although this is not bulky, but don't you feel that these crowded place will allow RO minus to enter? It will again hamper. So ultimately, if you form this product will be highly sterically hindered. So you can think of product also, or the same logic. Although I'm not bulky, but you are very much crowded, so rather I invest less energy, give hydrogen to this. The moment hydrogen electron is given, pi bond will move and this bromine will be lost. That means my product will be, so this C, this bulkiness will be intact, this carbon is intact, not allowed to enter base into its territory, and therefore again what alkene you have formed? Sir, again I have formed an alkene which is less substituted. That means it is again Hoffman product. I hope everybody is clear now. Perfect. Sir, last case, sir. The reason I have written initially that always beta, always that hydrogen is removed which is opposite. Always that hydrogen is removed which is opposite. So that means I have to check the stereochemistry of the reactant also. Now, let's say if I have given the question in this way, then the question is not being specific about the stereochemistry, so even I do not have to bother regarding it. Now, if this bromine is removed, then obviously this carbon hydrogen can be removed. If this can be removed, what will be your product? Sir, a methyl group and a double bond. Sir, if let's say, sir, if this is removed, sir, this CH2 is removed, I will be having a double bond here, and definitely this methyl is still there. So these are my two possibilities. But now you tell me, if I remove hydrogen of this carbon, the alkene formed is more stable, more substituted. Let us check hyperconjugation also. So hyperconjugating hydrogens will be 3, then 2, 3 and 2 is 5, 5 and 2 is 7 hyperconjugating hydrogens. What about this guy? Sir, 1 and 2. That means 3 hyperconjugating hydrogens. So obviously this will be my major product and that shall be my minor product, because the question is not being specific about the stereochemistry of the reactant. Now, if if I look at this compound, although the compound is same, this is 1 bromo 2 methyl cyclobutane, the cyclopentane. This is also 1 bromo 2 methyl cyclobutane, but here and here I'm being specific about the stereochemistry. What is this isomer? So cyclic chain is also a geometrical stereocenter. So here hydrogen, yes, comparing hydrogen and hydrogen of these two, because obviously this has both the groups same. So hydrogen on same side, that means sir it is cis form. Sir, hydrogens on opposite side, that means it is trans form. So if stereochemistry, stereo specific nature of the reactant is specified, then I have to check what, sir, technically which hydrogen I need, which will give me more substituted alkene, more substituted product. Okay, sir. But here this bromine is here, and the more substituted product I get from this carbon, and bromine over here is definitely present, hydrogen over here is actually present in the opposite direction. So definitely I have no problems. I will remove hydrogen and this will be my major product. No issues, sir. But if it is this isomer, then definitely I'm interested in hydrogen of this carbon. But this carbon's hydrogen and bromine are on same side, and I have told base cannot approach. So I will not even care whether what type of alkene. Base can't come here. So base will obviously approach this hydrogen, and rather this alkene is produced, leaving methyl over here. So here, what product you have obtained? So less substituted, that one. So less substituted product becomes the major product. So this is your Hoffman product. This here is again your Saytzeff product. I hope everybody is clear. I hope everybody is clear. Abdul is saying, sir, can you repeat? Abdul, what precisely beta you want me to? Definitely I can, but you have to be precise. And bol rahe bah. Chalo, Sinha Sahab is having peer-to-peer doubt discussion. Maybe. Abdul, Rashid, what do you want me to repeat, beta? Be precise. I'll be definitely doing it. What? Doubt. If you want complete things to be repeated, beta, then obviously you just hold for this, because after the live is done, you can definitely go to the recordings and watch it completely. But yes, you have to be precise. What is your doubt? I can definitely do that for you. Chalo, perfect. Now, next, sir, again you are discussing preparation of alkenes. Why? Because beta, this will be reactions of alkyl halide. If I have vicinal or geminal dihalide, although NCERT only discuss about vicinal, but you should know if I am vicinal also or geminal also. Vicinal is halogen on adjacent carbon, geminal is halogen on the same carbon. So if I have vicinal or geminal alkyl halide, then I can also form alkene using zinc dust. Why dust? Because that will increase the surface area of the solid catalyst in presence of mild acidic condition of either alcohol or carboxylic acid. It will create the corresponding alkene because zinc will be taking both the halogens as ZnX2. I hope it is clear. Very easy reaction, very probable NCERT reaction. Now, sir, one thing I have removed. What I have removed? I have removed the formation of alkene by alcohols. Why? This I will be discussing in the chapter of alcohols, because alcohol forming alkene is definitely an area of alkene, but I'm deliberately leaving it because this will make our alkyl halide discussion thorough, or rather bulky. I will definitely be discussing the elimination, but yes, let me just summarize by saying that like we have seen E2 mechanism, this elimination rather is E1. Why? Because here carbocation is produced. Why it is produced? Because beta, unlike alkyl halides where bromine, chlorine and iodine was having large bond length, this carbon and oxygen are both second period elements, so this bond is not easy to be broken. So you definitely first have to protonate this. Once this oxygen gets protonated, as in attains a positive charge, then it will become very angry. It will not even care whether this bond length is small or large. It will snatch electron of carbon, thereby producing a carbocation. Once this carbocation is produced, this becomes the first step. As in the first step of the reaction where carbocation is formed, and whenever carbocation is formed, that becomes the slowest step and hence the rate determining step. So in this step, how many reactant molecules I have? Only one. So molecularity becomes 1. So this becomes my E1 elimination. This becomes my E1 elimination. Yes, Neha, perfect. Yes, Neha, perfect. So this becomes my E1 elimination. And here this carbocation is formed. But sir, whenever carbocation is formed, it will keep on getting formed till it has stabilized. And in order to stabilize, it is first given a chance of ring expansion, and then it is given a chance of rearrangement. So I have definitely, after formation of this carbocation, in order to be quick, let me directly do this. This is carbocation formed. Once this carbocation is formed, the 4-membered ring will try to open up. So this bond over here, will be opening up and getting attached to this carbon. That means you get a picture like this, because this carbon has received electron, this carbon has lost electron, so positivity is here. Now, so simply drawing, that means this is a 5-member, this is a 5-member chain. Now, because positivity I have over here, so hydride shifting will take place and I get a carbocation at this guy. The moment I have carbocation over here, now this ring will feel I am 5-membered. I can make a 6-membered ring because carbon is just next to me. So this bond can do ring expansion and positivity will be coming at this carbon. So I will be getting positivity at this carbon, making a 6-membered ring. Now, sir, again, after this 5-membered ring will also think that this carbocation is just next to me, so I can also do ring expansion. So this will also do ring expansion, positivity will come over here. So ultimately you have both the 6-membered ring with positivity at this carbon. Now you do that elimination and you form your alkene. So technically, a carbocation whenever formed will keep on getting formed till it has completely stabilized itself. In order to stabilize a carbocation, first you do ring expansion, then you do rearrangement. A very famous example of JEE. This is a JEE 2023 question, 13th April. A beautiful question by JEE Mains, although this was initially asked only by JEE Advanced, but yes, this beauty was thrown, and that's why I told after 2023, around 2023, mains level of chemistry has also increased significantly moving forward. Now, coming to some reactions of alkene where production of alkyl halides will be happening, then that's why reading them. So first is addition of halogens. So if I have alkene, then sir, I can have addition of X2. The famous halogen that are added is Br2 and Cl2, again because of the fact I2 is very less reactive, F2 is violent. Now, what product you will be forming, sir? This is very quite predictable, sir. Sir, vicinal dihalides. So here I will be forming, this is R, this is CH, single bonded CH2. Obviously, I will be having this here also. Now, the fact which you have to learn for all level of questions, that I have told you hydrogen was small, so syn addition. But halogens are big, so definitely the addition will be trans addition. So bromine will come here and chlorine will also have a trans addition. Now, the next important point for bromination, is it is also a test of unsaturation. Why? Because bromine liquid, technically called as bromine water, although there is no water, bromine is just a non-metal present in liquid state. So bromine in CCl4. So bromine in CCl4 is your bromine water, which is a beautiful reddish or orange color compound. If it is there, then color is there, which is reddish orange. But if it reacts and after reacting it is forming vicinal dihalide, so the color will be gone. So decolorization of bromine water is rather a test of unsaturation. Moving forward. Now, sir, we have to learn the mechanism. Yes, for bromination or for halogenation, you have to. Now you tell me, what are the reagent that you have used? So Br2 in CCl4. Obviously, looking to that alkene, which is electron rich, the pi electron cloud will cover this alkene from both sides, upside also and downside also. So because pi electron cloud has covered this alkene, then definitely who can attack this electron rich benzene rings are only plus. So Br2 will have self ionization and form Br plus and Br minus, and out of that who will be approaching this benzene ring? That the positive, because positive will be loving electron, and hence it is termed as electrophile. So that means, sir, it is an electrophilic addition reaction. This pi cloud will be approaching this bromine, and once the approach is done, beta, once the approach is done, what product we see? Because the chemical, again I'm giving you this experimental fact, because obviously sometimes you have to bridge to those experimental facts, because beta we have definitely seen if carbocation is formed, then ring expansion and rearrangement happens. In case of bromination, when Br2 attacks, sir, no ring expansion or rearrangement was seen experimentally. So we have to design a mechanism where we have officially declared that no carbocation is formed. But sir, mechanism wise, plus minus will attract. So they are saying yes, plus minus will attract. But ultimately, this positivity will still be remaining over here, and instead of a carbocation, a cyclic brominium cation is formed. Now how this further reaction will proceed, sir? Let's say it has reacted from the top side, then the other Br minus has only option of approaching this intermediate from the opposite direction, hence the addition will be opposite anti-addition. So let us watch that addition. Let's say this Br minus is attacking this side, so electron will be transferred to that bromine. So ultimately, what is your product that you have produced? Sir, this pink color bromine will come here, and that pink color bromine will go there, this one. And whatever remainder bonds you have, they will be as it is. So this becomes your anti-addition. So this becomes your anti as an opposite addition. I hope everybody is clear with this too now. Now, let's say, sir, then product you can obviously form. Sir, you are asking us the product produced. So it is cis, it is trans. But sir, how come you are saying cis trans? Now for that, again, we have done tremendous amount of reactions, and we have seen that because we know these reactions are highly stereospecific and selective. So what reactant stereochemistry and what product stereochemistry, sir, both will be hampered. But sir, if let's say first form the product. If we form the product, it will be, sir, alkane. So this alkane will be having one bromine here and one bromine there. And what are its bonds? Make them as it is. So this is CH3, sir. This is H, sir. This is H, sir. This is CH3. But sir, this is a tetrahedral structure, but you are forming in a 2D plane. Let us form it. Now just name this. Now just name this, sir. 1, 2, 3, 4. 1, 2, 3, 4. Sir, it is a symmetrical structure. So whenever you get a symmetrical structure, once we have done experiment, then for all these symmetrical structures, we found that the product was always optically inactive. Why, sir? That was the question for many, because you definitely have chiral carbon, sir. So this is also chiral carbon and this is also chiral carbon. So if you have a chiral carbon, sir, ultimately product should have optical activity. Why it is not having optical activity? It was researched, and then obviously there are some conclusions, but I have a very nice mnemonic for you to learn that conclusion. The conclusion is the product is optically inactive because of team. Now this is not a bookish conclusion. This is GSA conclusion. This is Gaurav Singh Arora conclusion. Obviously product is optically inactive. That is an experimental fact, but I can learn some mnemonic, base some mnemonic on those facts. I have a mnemonic for you. Team. In team, T stands for trans. So in trans alkene, E is nothing. E is just for the mnemonic, the word team. If in trans alkene, if you do anti-addition, so Br2 is heading on an anti fashion. then the product is optically inactive, but it is optically inactive because of the formation of mesoform. Now with this, in alkyl halides also, you have to learn this, you have to understand this optical isomerism detail. So here also I'm giving you. Now what is a mesoform? Let me draw the Fischer projection of this. So once we have experimentally, because your optical activity can only be determined through polarimeter, you do not have any other means to check that. So then draw the Fischer projection. What is a Fischer projection? You draw the chiral carbons like this. You construct all the members of the main chain in the vertical line. And because you need a mesoform, so if I'm putting bromine here, hydrogen here, so I'm forced to put bromine here and hydrogen here, because mesoform is that compound where you have two different optical active stereocenters. But let's say if it is rotating light from Br to CH3 and it is rotating light from Br to CH3, then both have optical rotation which is exactly opposite, and hence they will cancel their optical activity, which will ultimately not allow the light to rotate. And hence this is called optical inactivity due to internal compensation of the molecule, and such an optically inactive molecule is called a mesoform. So because you form this with a trans alkene, because with trans, what alkene I was having? Cis. So obviously this trans will be the product. Obviously this trans will be the product in this case. So I am not drawing the normal product. Obviously, sir, but bromine has added from opposite direction. Beta, this is opposite only. Because stereochemistry, you are learning this because this is tetrahedral system. So they are opposite only. You cannot judge. Fischer projection is representation of the 3D molecule in 2D plane. So you can't say bromine on same side. It is in same side on the Fischer projection. On 3-dimensional plane, it will be definitely opposite once it has approached to a transalkene. And how I know meso is formed? By this keyword team, which is definitely experimental. This is a mnemonic from me to you. I hope everybody is clear. Now, so that means, why it is optically inactive over here? Now I'm giving you the mnemonic properly. So with this you learn, and if you learn this, then you transform your knowledge. How? So that means in trans, if NT is done, then mesoform is produced. Then do the opposite. That means that if cis will have NT, I will have optical inactivity due to racemic mixture formation. And opposite, if you have syn addition, so obviously this can be extrapolated, but yes, that will become an advanced topic, although because this is famous for with respect to NCERT only, but yes, you can obviously do the opposite. So with syn addition, as in from same side, sir, NT will form racemic mixture and cis will form a mesoform, but only when, not always, only when the product is symmetrical. Otherwise, it will obviously be optically active. So here what product you can suggest? Sir, obviously here I can suggest, let me not draw it like this. Let me draw the stereochemistry of the product. So let me use this rather. Let me remove this because I after this will be needing, this is not meso, that means I have Br here and H here, that means it is, this guy is perfectly optically active. But 50% of this will be formed, and if I put a mirror here, and if I put a mirror here, then what I'll be forming? Sir, CH3 here, so Br is here, so Br will come here, H is here, so H will come here. That Br will go to the farthest side, this H will go to the farthest side. So obviously this is also optically active, this is also optically active. But why it is a racemic mixture? Because 50% this has formed and 50% this has formed. Both has optical activity opposite to each other. So this will, let's say it is dextro, so that will be levo, hence 50% will have optically inactive mixture. So again, a very famous point, but I hope this is clear to everybody. Now, Sir, alkenes can also form alkyl halides not by addition but by free radical, because sir, you have already told us in presence of sunlight and high temperature homolytic fission take place. If my alkene is having allylic carbon, now what is this allylic carbon? Allylic halide will be formed with an allylic carbon, which is the carbon next to a double bonded carbon. Now what happens is, if you have sunlight or high temperature, then sir, you have already told us during such condition homolysis can take place. So if this hydrogen undergoes homolysis, it will be forming a radical, and this radical is not poor, it is very stable. Why? It is resonance stabilized, beta. This is a resonance stable intermediate. Hence, why the hell I will do addition? If sunlight is present, then homolysis will take place, and because homolysis is taking place, so this radical is formed. Again, if I have used a reagent NBS with sunlight, so they will also undergo homolysis. So what halide I have? Sir, you have bromine radical. So beta, rather use that bromine radical. Why? For chain termination, because this intermediate is stable. So this intermediate is stable. So this intermediate is stable and will do the chain termination with this bromine radical. Here, sir, bromine will also do homolysis because high temperature now. Sir, again bromine radical. Here, sir, chlorine at high temperature will also do chlorine radical formation, so chain termination with chlorine. So these are your possibilities. These are your possibilities for allylic substitution. I hope everybody is clear. Moving forward, next. Sir, why you have given that mechanism? Because beta mains have also got interest in this. What? Sir, first we know Br plus attack. And after that, sir, Br minus attack. But if you have not Br2 in CCl4, if you have Br2 with water, then sir, instead of Br minus, OH minus will attack, or rather lone pair of oxygen will attack, because they will have more nucleophilicity, as in they will be more attracted by the positivity. Hence, if you have Br2 in water, then definitely Br plus will attack, but OH minus will go, sir. OH minus and will go where carbocation is not formed. But beta, who will have more positivity? Carbocation is not formed, but think of partial positivity. This partial positivity will be 2 degree. This partial positivity will be 1 degree. So this guy deserves CH3 CH single bond CH2. If this partial positive, why sir partial you are saying? Because beta, there it has been seen that no rearrangement take place, so I can't afford to make a carbocation. But because partial positivity on this will be more, so this will attract OH more, this will attract the negativity more, and that guy was having Br. Although when Br was there was no question of judging this, but now there is definitely a question. And if it is CCl4, then you definitely know. If it is CCl4, then you definitely know. This is simple Br. Now, with this, there is introduction of again a basic thing, which is Markovnikov. Again, like Saytzeff, it is also a experimental law, but technically it fails in your mains examination. So what you should do, rather you should be confident with your basic only. What is that basic? Basic is, whenever you have an electrophile, first you create either carbocation or partial carbocation. This partial carbocation is only valid for Br2. Else, if you have any electrophile, just do add that electrophile, form that carbocation, make that carbocation stable by rearrangement or ring expansion, whatever possible. First stabilize that carbocation and then attack the X minus. But technically, this Markovnikov addition says that negative part goes to that double bonded carbon which has lesser hydrogen. With an idea, if you have less hydrogen, you will have a tendency to be a stable carbocation. But don't learn this, although you should know what is Markovnikov addition. I hope everybody's clear. Divyansh Gupta, yes beta, there will be live class for every chapter, NCERT based JEE preparation. This is what we intend to do for you in JEE, in YouTube, definitely free. Chalo, moving forward now. Sir, Why sir chemical reactions of alkene again beta? Because I have told you electrophilic addition generally proceeds via carbocation formation. So let us see this. If I'm symmetrical, sir, H plus will attack. I've already communicated everything, that's why written. So H plus, sir, carbocation will attack, sir, this carbocation. Why not that one, sir? Because this is stable, that will be 2 degree, this is 1 degree. Sir, it can't further stabilize, so no, do not think of any rearrangement. Make X minus attack and you get your Markovnikov added product. So because again this is an alkyl halide, so again important for your alkyl halide chapter, and this mechanism is nothing but nucleophilic addition reaction. Sir, that means if you have alkene and alkyl halide, then always Markovnikov addition will take place. No. If you have alkyl bromide in presence of peroxide, then opposite will take place, known as anti-Markovnikov or peroxide effect, or rather Kharash effect, the scientist. Why? Because mechanism changes. Because sir, you have sunlight. So in presence of sunlight, what will happen? Sir, first free radical will be formed. Let's say this is my radical initiator. So it will undergo homolysis, sir. It will form RO radical, sir. This RO radical will trap hydrogen of Br. HBr will form ROH, creating Br radical, sir. Now this Br radical is mad, sir. It will think of attacking. Who is present for the attack? Sir, the alkene. So it will rather attack the alkene. It will rather attack the alkene. Now, if this guy is going to attack alkene, although this is electron deficient, that is electron rich, although we say this is attacking species, but mechanism always direct arrows from higher concentration of electron to lower concentration, because pi also want to become sigma, the common sense of bonding. Now, radical can form here, radical can form here. Where radical is stable, sir? Again, 2 degree electron deficient species, sir. So which radical shall I form? Sir, definitely more stable. So common sense is same. But because attacking species has been substituted, it is not H plus, rather it is Br radical. So I get a radical here. And this radical will definitely further attack HBr for chain propagation. Br radical will again be released, and the chain termination, and this chain termination will be achieved by the hydrogen of this HBr producing Br radical, which is ready to attack another alkene. Hence it will be keep on happening, and you will be getting a product where negative part of attacking species has attached to that carbon which has more hydrogen. But again, sir, this is also probable and possible. I hope everybody is clear. Now, moving to some more reactions, although it has got nothing to do with it, but because we have discussed everything. So Markovnikov, sir, water, that means OH will go here again because carbocation is stable. If I have concentrated sulfuric acid, then I have H plus attack, then I have HSO4 minus. So O minus, S double bond O, double bond O. This is actually bisulfate. This is actually bisulfate added according to Markovnikov addition. Moving forward, because we have discussed everything, so let us quickly finish this also. Like Br2, Bayer's reagent is also a dark colored solution. Whenever it is there, its color is there. Whenever it reacts, its color decolorizes. So decolorization of Bayer's reagent is also a test of unsaturation. But these are oxidizing agent, where Bayer reagent is a mild oxidizing agent. So mild oxidizing agent will rather break only pi bond. So once only pi bond is broken, what product you are forming? Sir, vicinal diol. When you have ozonolysis followed by zinc and water, that is reductive ozonolysis. It will also add water. It will also add oxygen, but oxygen as is added as you see the double bond, you break the double bond, and you introduce double bonded O. So this is double bonded O as an aldehyde. That is also one carbon aldehyde. So it will be HCHO as in formaldehyde. But if you have strong oxidizing agent, or rather you have oxidative ozonolysis, when you don't use zinc, just use ozone followed by water or followed by H2O2, that becomes oxidative ozonolysis, which is same as action of strong oxidizing agent, which is nothing different. You do the first step which you have done in ozonolysis, you again do that. But the only problem here is because this is strong oxidation, so this H is also substituted by OH, because strong oxidizing agent will not leave any carbonyl H. So this H will also not be there, replaced by OH. So these two hydrogens will also not be there, replaced by OH. Sir, you have already told one carbon having two OH is gem diol unstable. So dehydrate, that means it will be nothing but CO2 and H2O. That means if you have one carbon, it will be CO2 and H2O. I hope everybody is clear. Hello. Hello. Chalo, perfect. Moving to now a very interesting topic again from the chapter of alkyl halides, which is thermodynamic and kinetically controlled product. Now why? It is only applicable for the case of HBr. Why? Because advanced started it and mains is using it like anything. So you should have to know this for mains also. For HBr beta, even room temperature is very high temperature. And at very high temperature, you do not think about intermediate stability. Why? Because as per chemical kinetics, reactant has to reach activation energy barrier. Who can reach that activation energy barrier? Only strong intermediates. But if you have increased the temperature for particular reactant to such a large extent that reaching activation barrier is no issue. So at elevated temperature, you don't think about intermediate stability, because every intermediate can cross that energy barrier. So what you will think about? Think of the stable product. And because for HBr, even room temperature is that high temperature. That's why for HBr, if you have a diene, conjugated diene, so these are reactions of dienes. Now what happens is, sir, common sense we know. Sir, H plus will attack. It can attack from here also, wherever. So if I have these 4 carbon atoms where they're here already, so where you will first form the carbocations are here. But sir, obviously we know this carbocation is resonance stabilized, therefore it can rearrange also. So these are my possible carbocations. Agreed. Sir, I definitely know this is 2 degree allylic, this is 1 degree allylic. This is also resonance stabilized, this is also one resonance stabilized, and out of that this one is more stable. But if this guy receives, let's say, Br minus, so product will be, sir, 4 carbons, double bond here, Br here. If Br is here, then you tell me where H has gone. Sir, because you have formed carbocation here, so this H has definitely gone to this carbon. So ultimately this is 1,4 addition product. But sir, this is less stable carbocation, but look at the product beta. Hyperconjugation is, sir, 3 and 2. This is more stable product. This is more stable and conjugated. This is more hyperconjugated alkene. If I have attack at this carbon, as in the intermediate which is more stable, if this is getting bromine, then the hydrogen was obviously added in the, so this is called 1,2 addition. So this addition will definitely be done when, sir, we always think of intermediate. I'm not asking you to not think of intermediate, but beta, if temperature is very high, sir, how the hell we will know temperature is very high? That you have to learn for HBr. So this is an inorganic knowledge that you need to know, that for HBr, not all. For HBr, even my dear room temperature is very high temperature. So every and any intermediate can climb that barrier. So that means I can also have and you can also have. Now who will decide? So this product is more stable or that product is more stable? So this is more stable. So this will be my thermodynamically controlled product, the TCP, and this will be my kinetically controlled product, which is 1,2. So basic for HCl you do not have to worry. So for HCl, what do you think, sir? Intermediate stability. Intermediate stability will form what? Sir, it will form 1,2 product. So intermediate stability will form, sir, here Cl, there H. That is, this is 1, 2, 3, 4, as in 3-chloro-butanene will be your answer. If HBr at 40 degrees Celsius, as in room temperature, sir, it is very high. That means what product you will be forming? Sir, thermodynamically controlled. That means 1,4 addition, sir. And again, if HBr is taken at very extremely low temperature, now, but inorganically, you should know this also. What? That minus 80 degrees Celsius is actually very less temperature. And at this temperature, I cannot think of product stability. Only that intermediate will form product which has the aukat, which has the potential. So here also, what will be a product? The kinetically controlled product. I hope a very interesting point, a very simple one rather, but I hope each and every one of you knows this now. Hello. Chalo, perfect. Perfect. Moving to the next one. Now, there are some questions, beta. Yes, definitely you can attempt these questions. Sir, where we will get these questions? Sir, in the WhatsApp channel, PWJ English. So, because I've discussed the mechanisms also, so just the application of those mechanisms will be these questions. Now, coming to alkyl and aryl halides now, because we have done almost everything, so we can learn alkyl and aryl halides in a jiffy. How? First, the classification. Sir, if there is one, it is mono, two di, three tri. It can happen in alkyl halide also and aryl halides also. So first points are obviously clear to everybody. Now, next, sir, then classification is on the basis of carbon to which halogen is attached. If halogen is attached to an sp3 hybridized carbon, then it is called an alkyl halide, generally written as Rx. It can be 1 degree if halogen is attached to carbon which is directly attached to only one alkyl group. It can be 2 degree, it can be 3 degree. 3 degree is also termed as tertiary, 2 degree is also termed as secondary, 1 degree is termed as primary. Then you have benzylic halides. Benzylic halide are also sp3 hybridized carbon. Why? Because benzylic carbon is carbon next to benzene. So if this carbon is attached to halogens, this carbon is sp3 only. So benzylic halides are also sp3 hybridized carbon. Most of the students are confused in this. Please don't be. Now, sir, if it is, it is not, this carbon is connected to benzene, at least carbon. So this is 1 degree benzylic. It can be 2 degree, 3 degree as well. Now, what is allylic? Sir, benzylic is also an allylic. Why? Because what is allylic? Carbon next to a double bonded carbon. Sir, benzene is also double bonded. So benzylic carbon is actually an example of allylic halide, which is simply double bonded carbon, the carbon next to a double bonded carbon, if that is having halogen. So it is your allyl halide. Definitely, this can also be 1 degree, 2 degree, 3 degree, depending upon the substitution which this carbon is having. I hope everybody is clear. I guess I do not see that comment section now. Let me just check. Chalo. Guys, I hope. Let me just refresh the comment screen. Chalo. Now the comments are coming. Chalo. Good. Perfect. Perfect. Superstar is always there. Chalo. So these are the classifications. Now what next, sir? Now what next, sir? Kya? Chalo. Perfect. Now, sir, next, beta, vinylic halide. Now, in order to understand vinylic halide, which you obviously should definitely know, the vinylic halide are if I have a double bonded carbon. And if this double bonded carbon is directly attached to halogen, this is called a vinylic group. That means, sir, aromatic halides. What are aromatic compounds? Are benzene ring already having that double bonded system. And if this double bonded carbon is connected to halogen, this is aryl halide. That means, sir, vinylic halide. Aryl halide is an example of vinylic halide. I hope everybody is clear. Now, sir, geminal and vicinal halides, I already know. You should learn their general naming also. If double bonded carbon has 2 bromine, if ethene has 2 bromine on geminal position, it is called ethylidene bromide. If it is in vicinal, it is called ethylidene dibromide. And NCERT general naming beta, so very important. Most of the student miss this, that which is ethylidene and which is ethylene. Then I have a mnemonic for that also. Gem, just think of gem. You are moving in a road, you found gem lying on a road, you pick that gem. In Hindi, what you'll say, chandi ho gayi. Chandi as in gem. Eid ho gayi. Like you say, Arey wah, you got that. Eid ho gayi teri to. You have got a festive offer. So Eid is a festival. So once you get gem out of the blue, Eid ho gayi, this ID, that's why I've changed the color also, that if you found gem just like that, your festive season has started, Eid ho gayi. So ID comes in gem, else it is ethylene, or else you could have made some other mnemonics also. Moving forward now. Chalo, perfect. Chalo. Now, I hope everybody is clear. Now, these questions, obviously, because isomerisms we have already discussed, so you should definitely attempt these questions. Very great and good questions. Now, directly coming to the dipole moment, because they have polarity, so they will be more reactive as alkanes. Who are more reactive? Alkyl halides. So let us talk about their dipole moment for a bit. So definitely, if you, this is a NCERT data beta, very useful NCERT data. We definitely know dipole moment is a property of charge. This mu is definitely charge into distance between charge. But sir, dipole moment is a property of charge. So if we compare the dipole moment of only methyl halides C bond X bond, then definitely sir, I know this is minus and this is plus, and because it is a property of charge, so you tell me who is least electronegative. Sir, iodine. So delta negativity will be least, hence dipole moment will be least. If you check this by the data, yes, dipole moment of iodine is methyl iodide is least. Then sir, of methyl bromide, okay sir, this is common sense. But if you just check the dipole moment of fluorides and chlorides, then actually fluoride has one. This is first and this has came second, sir. But fluorine is more electronegative. Fluorine and chlorine are both electronegative elements. Yes, fluorine is more, but chlorine is not a loser. Chlorine has came second. That doesn't mean chlorine is a loser. Yes, you have more, I have less, but both are highly electronegative. On the contrary, because this charge has, yes, compensate, I mean fluorine is more electronegative, so this charge factor will be more, but not that more. On the other hand, the bond length, this D is bond length between C bond X bond. Sir, second period element are very small, and if you move along the period, size even decreases, and fluorine is the last element of the second period element. That means its size is very, very small, and down the group size increases like anything, so chlorine is very, very large. That's why this D factor has transformed the dipole moment of methyl chloride into such a value that it has slightly increased, not much, but slightly increased. So dipole moment of methyl chloride is highest, and then methyl fluoride, a very important NCERT fact. Now, again, sir, dipole moment is a property, sir, it is a vector quantity. Magnitude we have seen, this is magnitude, and sign will be from positive to negative. That's why if we compare the dipole moment of para isomer, the mu will be definitely 0. And if you compare dipole moment of ortho and para, then definitely this angle is 60 degree, this angle is more. As you increase angle, the vector addition is mu1 square plus mu2 square plus 2 mu1 mu2 cos theta under root. As value of theta increases, cos theta will decrease. So ortho has highest, then meta, and obviously para has least dipole moment, but so will be the approximate order of their melting point, boiling point. But again, sir, who do you melt? Beta, we melt a solid. So melting point of para will be highest. I hope everybody is clear, which we have already discussed in alkanes. So these are some again practice questions for you for learning, because these are very famous questions from alkyl halides also regarding their properties, which we have discussed in alkanes. So I will be giving you these questions, but they will be your homework. If you have any doubt, you can obviously go to the comment section and ask these conceptual doubts. But because I'm discussing concepts, so application of concept has to be your job. Okay, chalo, perfect. Now, sir, next, now we have landed to the chapters of alkyl halides, sir. So let us quickly finish it, sir. How beta? First thing is preparation. Alkyl halide preparation. Very first preparation is from alcohol. How from alcohol? You just replace this OH. You just replace this OH by any halogen. How to use it? You need some reagent which can create that X minus as nucleophile. Why I'm saying nucleophile? Because this is minus, this is plus. If I use concentrated HX, X minus will remove OH. if I use concentrated HCl in presence of anhydrous ZnCl2, reaction will become more and more fast. Why? I will be telling it, but this process is called Groove's process, and this reagent is called Lucas reagent. Again, chloride will be formed. If I use NaBr in H2SO4, I'll be getting RBr. If I getting NaI in H3PO4, I'll be getting Ri. If I'll be using PX3, I'll be getting whatever X I've used, that X, but here byproduct is also important. This is an inorganic fact. It will be H3PO3. If I use red phosphorus and X2, it will definitely create PX3 because PI3 is the bond length is very large, therefore PI3 bottle is not formed. So rather we create PI3 using red phosphorus and I2. So that will also give RX with same byproduct, sir. If I use PCl5, because pentahalides of chlorine is also only known, so if I use pentahalide, I get RCl with POCl3 and HCl. And last two processes are thionyl chloride and thionyl chloride and pyridine. If we just use thionyl chloride and my reactant is optically active, product has same optical activity because there is a retention. But if I use thionyl chloride in presence of pyridine, then my product becomes, if reactant is optically active, then product becomes optically active only, but will have inverted as an opposite optical activity, because here reaction is SNI and here reaction is SN2. Now what is the difference? That I'll be definitely discussing with the mechanism. Okay, chalo, perfect. Now discussing the basic mechanism of anhydrous ZnCl2. Now sir, what is happening over here? We have definitely seen that this C bond O is very small. So in order to break, I have to do protonation. And actually, in order to break this HCl also, I have further used a catalyst in order to increase the rate of reaction. ZnCl2 is a Lewis acid. This Lewis acid will drag chlorine. Ultimately, it will form more of H+. Ultimately, it will be protonating more of alcohol. Ultimately, it will be removed and you are going to produce your carbocation. So that will be the first step and the slowest step. Definitely correct. Which carbocation can be formed easily? So 3 degree. So what will be the reactivity of alcohols? So 3 degree will be most reactive. In fact, 1 degree will not at all react. Which, let's say, sir, in presence of, instead of HCl, I use HI beta, it will be more reactive because more H plus can be given. But sir, why you are specifically using HCl? Because beta, whenever you form alkyl chloride, you can see its formation. So that's why it becomes a physical test also. How you see this? Because it creates a white turbidity, white dhund, white effervescence. And that white turbidity, if you see, you can check that whether it is happening quickly or rather slow. If it is a 3 degree carbocation, then with this Lucas reagent, you form white turbidity immediately. That means this is a 3 degree alcohol. If white turbidity is obtained after 4-5 minutes, that too after heating, that means you are a 2 degree alcohol. And obviously, or technically, this doesn't mean you are reacting, but if you are reheating it for 30 minutes, so technically we don't do it, but yes. Because 1 degree carbocation is not at all stable. So if you use 1 degree alcohol, then you have to heat for 30 minutes and then you get your white turbidity, because 1 degree carbocation will not formed. It will require high amount of temperature to be formed forcefully. I hope everybody is clear. Now, moving forward, sir, in lab method with NaI, we have used H3PO4 specifically. Why you have written, sir, H+? Because generally you cannot use any other acids like H2SO4. Why? Because that will definitely create I-. But this I- will not be used to form Ri. Why? Because this I- with in the presence of H2SO4, H2SO4 acts as an oxidizing agent for I-. H3PO4 do not do it, because, sir, we have seen electrochemical series in electrochemistry. If you have not seen, then obviously we'll be discussing electrochemistry also, that the possibility of sulfuric acid acting as an oxidizing agent increases because it has more potential to do it, and it oxidizes I- to I2. So if I- is not available, how come it will be forming Ri? That's why if we use H2SO4 in presence of H3PO4, then that process is not done. I hope so. You have to specifically use only and only phosphoric acid H3PO4. Now, the mechanism which I have discussed, if you only use thionyl chloride, then the first reaction is quite relevant. This oxygen will go, it will take electron of hydrogen, H plus released, HCl gone. So this one chlorine will also go. Now, I formed this. But sir, here, this chlorine can give electron from the same side. The moment it is giving electron, oxygen is also very much happy to give electron to this sulfur. The moment electron is transferred, the sulfur will be releasing electron to this chlorine. Sir, electron cycle completed, so SO2 gas released, and I have formed alkyl iodide from the same side from where leaving group has gone, because this substitution is done internally. Hence I get RCl, which is having same optical activity because I have added from the same side. Rather, if you do use pyridine, then this pyridine will first attack, because sir, these lone pair are perfect base. So if they come, why they are coming in sulfur only, sir? Because sulfur is having +4 oxidation state. +4 oxidation state of sulfur is a highly beautiful positive electron deficient center. So this base will give its electron. The moment this base will give its electron, this O oxygen pi bond will take that minus. It will be very happy to take this minus. Now, because this is having excess of electron, so the moment this guy will give back that electron, this chlorine will be forced to leave. Why? Because bond length is more. Chlorine will be very happy. Here chlorine was not offered electron. Here chlorine is offered electron initially only. So Cl will be left in form of Cl minus. Now this Cl minus, if attacked to this carbocation, it has to be a backside attack, because that is electron rich species. This is also electron rich species. So this is a perfect backside attack. So this is a perfect SN2 mechanism. Hence the product that you will be forming will be an inverted product. That is why optical activity, for good questions, you should remember for what is SOCl2? Thionyl chloride. So thionyl chloride without pyridine is SNI. Thionyl chloride with pyridine, a base, is SN2. I hope everybody is clear. Now, again, some questions to attempt them. For alkanes free radical substitution, some questions, because I have already discussed it. So, but a beautiful question. You should definitely give it a try. Now, for alkenes, these product homework, because sir, HX Markovnikov, sir, anti Markovnikov, sir, vicinal dihalide, and sir, allylic substitution. I hope I have told everything. So these are just for your practice. Now, sir, now halogen exchange, which in the start of the class. So see, if you use NaI, Finkelstein will transform halogen into alkyl halide. Sir, with alkyl halide, you are forming alkyl halide. Why? Because beta, chlorides and bromides, you have formed how many, using how many reagents? And many reagents. So industrially, if a product is obtained by many process, then it will be cheap. So I can use that cheap reagent to form this expensive expensive product. So alkyl iodides are produced using Finkelstein. And if you use any metal fluorides, if you use any of these metal fluorides, then they will give F minus as nucleophile, producing alkyl fluorides. I hope everybody is clear. Now, next is, sir, a preparation of some more preparation. Although you can leave this. This is not even there in NCERT and very less asked. So let me remove this only. Let me remove this. Chalo, next, sir. Sir, next we have, okay, sir, we have not discussed aryl halides. So let us discuss aryl halides. How can you prepare aryl halides, sir? If I have benzene, sir, benzene is electron rich species. If I use Cl2 in presence of Lewis acid, then Cl plus will be created forcefully, because generation of electrophile. The moment Cl plus will be created, it will be attacked by benzene ring. But sir, aromaticity will be gone. No, the moment aromaticity is gone, the hydrogen removal take place and aromaticity is regained. This is your SE reaction. So you will get your chloro substituted benzene ring. Now, sir, this chlorine is plus R also and minus I also. Why So technically resonance is more dominating than inductive. Then why you are saying plus R and minus I? Because beta, the resonance which is happening between any halogen and carbon is not strong. Why? So because carbon is a second period element, so it will be making that pi bond with 2p orbital. Chlorine will be making with 3p, then bromine 4p, then iodine 5p. Sir, we have learned in organic chemistry. Sir, we have learned this in organic chemistry that, sir, dissimilar energized orbital have very weak extent of bonding, and because this is very weak extent of bonding, that's why resonance of halogens are rather very less, and because they also have empty d orbital, so if I can give electron, then I can take also. So ultimately also they are inductive, so they are strong minus I groups. So for them resonance is very weak, and that's why their inductive dominates. So ultimately if they are added to the ring, they suck, they take away the electron density. That means they deactivate the ring. That means this ring is not activated. Electrophile will not feel very much happy. But yes, if you forcefully create an electrophile using Lewis acid, then where they will attack, so directive influence will be decided by inductive. Their resonance very small, but ultimately that small electron density, because of that small electron density, I am coming who, these forcefully created electrophiles. So where they will be attacking, at ortho and para position. So directive nature is decided by resonance, but ultimately it is minus electron withdrawing group. I hope everybody is clear. And out of ortho and para isomer, which will be major product? Sir, para is having lesser crowding, so this will be your major product. Now if I will be giving electrophile to this guy also, then sir, if you are supplying, so benzene ring is actually electron rich, so every place bromination will take place. So you will be getting perfluorobenzene, also written as C6Cl6. I hope. Obviously you can form directly also by using excess of chlorine with Lewis acid. Why I have written dark over here? Because this thing you should know, that if you use a traces of sunlight, this we have already seen, but if you use even a small trace of sunlight, then beta, in presence of sunlight, instead of this substitution, because now I'm using toluene, so this CH3 guy will form a radical, remember, and therefore free radical substitution will take place. A beautiful example, a beautiful reaction, a knowledge we have just acquired in the previous slide. And sir, if I use benzene and I do chlorination in sunlight, then you will be forming C6H6Cl6, because even benzene ring, because sunlight has so energized photons, it will not even care whether you are stable or not. They will break every bond. Obviously those pi will also break, and that time you will be having addition. So C6H6Cl6, also known as gemexane or lindane, a very powerful insecticide. Now coming to another reaction, sir, aromatic, you said there is one naming reaction, Sandmeyer's reaction is benzene diazonium chloride, which is formed when aniline react with nitrous acid, because nitrous acid is unstable, so rather we make this acid using NaNO2 and HCl. Yes, why the 0 to 5 degrees Celsius? Because beta, nitrogen gas is the most stable diatomic molecule, so it has ability to just take the electron of any and everybody, although you are resonance stabilized or whatever you are. I will take those electrons and nitrogen gas will be released. You want the nitrogen gas to hold for some time, so you decrease the kinetic energy, and in order to decrease that kinetic energy, what temperature I am using? Around 0 to 5 degrees Celsius. And that's why this benzene diazonium chloride salt stay for that. Sir, if I use alkyl, then also they'll stay? No, because ultimately, first, temperature is reduced. Second, you can obviously see resonance happening. And because of happening of resonance, this sigma bond is also having partial double bond character. So even you take 0 to 5 degrees Celsius in alkyl diazonium salt, still nitrogen gas will be liberated. Only aryl diazonium salt are known to exist, that too not always, at ice cold condition of 0 to 5 degrees Celsius. I hope it is clear now. Sir, what else, sir? Beta, after that, if you have this starting material, then you can do your reactions. Or what are my reactions? Beta, use any nucleophile because this will be getting positivity. You use any minus. So if you use cuprous halide, you will be forming you will be halobenzene. If you use Ki, you will be getting iodobenzene. If you use fluoroboric acid, then first you get benzene diazonium fluoroborate. Why? Because this is beautifully a salt which is even stable till room temperature. Very important point. And therefore, in order to further form fluorobenzene, you have to heat. Many times JEE has done that. After forming this, you have to heat because it is stable till room temperature. And once you heat, then this BF4 minus will be released in form of BF3. Nitrogen gas will be released, and what that extra F minus you will have will be introduced to the ring. This will create fluorobenzene. Hello? Hello? Perfect. Now, sir, some reactions. Now, sir, elimination reactions already done. So now this job is done for us. Reaction with metal, sir, in alkanes we have done. So this is also done. The only reaction we are left with is SN reaction. So quickly and directly move to SN reactions. So quickly and directly move to SN reactions. Now, that is also very probable and very clear. Yes, you can understand and learn more of this using examples. So, but let me give you a precise way of looking at it. Now, first thing is, if my whatever is this SN reaction, why it is happening. So, okay, let me explore that thing first. Just this basic thing that why this SN reaction is happening. Beta, most of the student only think of the crowding. Beta, please don't do that. Why? If I have alkyl halides, then definitely this much I have seen that because of polarity, this is minus and this is plus. Sir, this I know. If I have a positivity over here, then definitely I can think because of this positivity beta, not because of any other thing. Because of this positivity, this nucleophile is attracted and this halogen will leave. This constitutes your nucleophilic substitution reaction. Definitely done, sir. What else, sir? Beta, the first reason, the basic reason why nucleophile is approaching is because of the electronic factor. The second factor is this is most dominant and students don't remember this. They remember this in the chapter of carbonyl compound, but here they forget. And this is what JEE has checked so many times. Once electronic factor is almost same, then you check whether nucleophile is coming, it is feeling repulsion, hindrance from the crowding or not. If it is crowded, it can't come. If it is not crowded, it can easily come. But then you think of the steric factor. So please always make sure you do this. Now come to the basic. If this carbon is not at all hindered, then this nucleophile will attack. How, sir? It will attack in one step. Backside attack will take place, and the moment backside attack takes place, this Br minus will this OH minus will approach from the backside with respect to halogen. So this halogen is just leaving, this nucleophile is just coming. That means I have formed an intermediate stage which is trigonal bipyramidal, and then I have an inverted product. Because it is a single step process, so reactant will climb the activation barrier and will form the product. As I have told you, why this nucleophile is coming? Because of positivity. So if I introduce electron withdrawing group, that I'm increasing the positivity. So nucleophile will be very much willing to attack, to substitute. That's why it will be coming with a larger kinetic, larger velocity, larger speed. So as per chemical kinetics, why speed is getting increased? Because nucleophile has provided an alternate path. That means if electron withdrawing group is connected to alkyl halide, then activation energy is reduced, and that's why reaction becomes faster. I hope everybody is clear now. So these are some facts, obviously good facts. So just have a look at them. If you feel you need any add-on, you can definitely go in the comment section. But yes, I have given some good conclusions, not discussing all, but yes, very good conclusions. So all of you who are serious enough should definitely read this. find any doubt, obviously these will be continued in the remaining weeks also. So you can definitely hit the comment section. I'll be coming back. But yes, for that I need your inputs. Accordingly, you will be served. Now, sir, if the carbon is bulky, sir, then beta, if the carbon is bulky, then backside attack cannot take place. If backside attack cannot take place, then what, sir? Substitution won't take place. Beta, you have already seen it. Ionization will take place, but sir, ionization will require water. So the point to be noted is, for SN1 you need a polar protic solvent like water, because that will allow the ionization easily. So ionization will take place. So perfect carbocation. But yes, okay. So step 1 will be, in presence of this polar protic solvent, I get a perfect carbocation which will be trigonal planar. And now whether I was bulky, because I am planar, so attack can take place from this side also and from this side also. So whatever was my optical activity, 50% will be retained and 50% will be inverted. So if reactant was optically active, here product will be optically inactive, but only because of racemic mixture formation. This constitutes your SN1 mechanism about the chemical kinetics, because it is a two-step process. So step 1, sir, carbocation formed. Step 2, product formed. Again, from step beta, you always in each step you have to climb an activation energy barrier. But here activation energy barriers is longest, so this will be the slowest step. Obviously, you know carbocation is formed in the slowest step. Again, a very beautiful table for you to have. Obviously, a very beautiful table. Please, please, please. If you find any, then obviously for getting something extra, I need inputs from you. Now, although for a mains level of examination, this is more than sufficient. So yes, the point is, for SN2 reaction, you need solvent which is aprotic, or else ionization will be preferred, and if ionization is preferred, then SN1 will take place. You do not have to worry about the leaving group ability, because whether it is SN1 or SN2, at least halogen has to leave. So Ri is least reactive in both of the cases. But yes, if you talk of the degree, then SN1 is preferred in 3 degree, because I need stable carbocation, and if I have methyl of 1 degree, then rather it will always undergo substitution using SN2. I hope everybody's good. Now, a basic example, this you can obviously practice. The second one, beta, whether it is SN1 or SN2, that's what I was saying. Whether it is SN1 or SN2 doesn't even matter. Why? Because first factor is electronic factor. So this will never undergo SN reaction, because aryl halide, sir, partial double bond character. So this resonance will make partial, so no reactions, no SN reactions of alkyl halide is given by aryl halide, so not even comparing. So this guy is having positivity because of minus I of the ring. This is not aryl, this is sp3 hybridized. So this is having nothing, sir. Sir, here I have a carbonyl group, sir. It is strong electron withdrawing, sir. So because now, am I seeing any steric hindrance? Beta, this is a JEE advanced question, and that is what they do. You should first think why nucleophile is coming, because of charge. So this is creating best charge. So this will be this. Let's say this is A. So this A will be most reactive, whether SN1, SN2 doesn't even matter. Then sir, Delhi. This is Delhi. So then Bombay, and C, I am not even writing. So you should definitely attempt these type of logical questions, which will definitely help you to gain the confidence also. Like now, if I have a non-polar solvent, organic solvent, polar aprotic solvent, polar solvent, but aprotic, no H plus. So sir, this is my nucleophile. Sir, aryl halide won't react, sir. But yes, this will react, sir. And how beta? Perfect SN2. So what product I'll be having? Sir, the same product, sir. Just change the orientation, sir. So nucleophile is sulfur substituted with phenyl. So this is methyl, this is fluorine, and double bond. Now, sir, what are the nucleophiles present? If I use base, OH minus product will be alcohol. If I use water, then this is a neutral nucleophile, but still it can produce alcohol. Yes, OH minus will be a better nucleophile. Water will be a weak nucleophile if you compare with OH minus. If I have this, then RO minus is the nucleophile, so product will be ether. If I have NaI, then I minus will form Ri. Ammonia, sir, again neutral nucleophile, but still, sir, lone pair is there, so it will give electron, take electron from hydrogen, so this NH3 will become NH2, forming 1 degree amine. 1 degree will form 2 degree, 2 degree will form 3 degree. These are ambident nucleophile, because KCN is a salt, so it will completely dissociate and give Cn minus. So carbon is having minus, so obviously carbon will give electron, nitrogen will not give, because more charge, more easily given. So here the alkyl group will be connected with R, so this is RCN, that is nitrile or cyanide is formed. If I have AgCN, then you can obviously see, sir, it is a covalent salt. Nitrogen is carbon is not having minus, sir, how it will give? So only nitrogen can attack lone pair. So here R will be collected to nitrogen, producing isocyanide, very important point, and these nucleophiles are therefore known as ambidentate nucleophiles. Similarly for, so this will give NO2 minus, this will create AgNO2. So here oxygen and nitrogen both have lone pair. Who will give their lone pair? So nitrogen. Why? Because oxygen is more electronegative. That's why here nitrogen will ligate, so nitro compound is formed. Here oxygen will ligate, so alkyl nitrite Te is formed. I hope everybody is clear. Sir, if I have silver salt of carboxylic acid, then I have complete minus in oxygen. So this O minus will attach with R and form ester. Sir, with lithium aluminum hydride, I have H minus as nucleophile, forming RH. If I have a metal, then this metal will be plus, and any alkyl group will act as a minus. So that minus will add to R of alkyl halide, this RX, and will form higher alkane R dash. I hope everybody is clear. Now, almost done, beta. Sir, this is sodium alkynide, again a salt, sir. So this will give R minus. So this minus will attach to R. Sir, if I have NaSH, so SH minus, it will give, instead of ROH, RSH. So this is not alcohol, this is thiol. So ultimately, sir, with alkyl halide, I can do nucleophilic substitution, and practically I have formed all the classes of organic compounds. Yes, hence definitely very important. Now, eliminations are already done. Where? Beta, in the chapter of alkenes. That's why I have deliberately added that chapter with you. Now, reaction with metal. This is just an example. We have completely done it with example during alkanes. Now, this is how organic becomes shorter, once you conceptually do the complete thing. But still, given you everything. Yes, a very good point, beta. A very good point that if you compare electron withdrawing nature, then chlorine has highest. If chlorine is attached to benzene, it will withdraw electron to the highest tendency. Why not fluorine, sir? It is minus I. Because beta, for if you just remove this, then there is no problem, because you know this is most electronegative. Then why, sir, fluorine here less? Because beta, chlorine is highest minus I, but its plus R also will be operational, no? Because it is 2p, carbon is also 2p, so 2p, sir, then it's but then, sir, why it is electron withdrawing? Because its inductive is also very highest, na? Although its resonance is perfect, like simple resonance, but because this is highly electronegative, that's why it is also, because of its plus R also, it is not able to give electron. It withdraws electron only because its minus I is strong, super strong. But if you experimentally compare the electron withdrawing nature of chlorine wins as compared to fluorine, but yes, a very good point. So experimental fact, loved by advanced, never has been asked by mains, this thing. Sir, reaction in metal, fatigue, we have already seen. So last reaction, sir. Sir, now these aryl halides are plus R. So some more example. Sir, nitration will give NO2 plus. So NO2 plus will be added at ortho and para. What will be major product? Para isomer. Who will be nucleophile? Sir, HSO3. So sulfonic acid will be formed. Ortho para. Who will be major product? Para. Chlorination, sir, Cl. Who will be electrophile? Cl plus. So this you can definitely attach and form the para isomer. Sir, Friedel-Crafts alkylation, Lewis acid is anhydrous AlCl3, so CH3 plus will be your nucleophile. Orthopara, para will be major. Here nucleophile will be, sir, CH3 CO as an acyl carbocation. Orthopara, para will be major product. I hope I am giving every detail moving forward. Now, हाँ sir. Sir, this already you have told all the reactions of alkyl halide, the SN reactions will not be given by aryl halides. Why? Because of partial, why? Sir, because of partial double bond character, point number one. Because of shorter bond length, obviously partial double bond character will decrease the bond length, so smaller bond length, sir, high bond energy can't be broken. Sir, some people think make carbocation. No, because if this sp2 hybridized benzene ring will have positivity, that phenyl cation is also unstable, and it is obviously it is difficult to approach electron rich ring. So nucleophile is also minus, ring is also minus, so minus minus will repel each other. But these four factors are NCERT written factors, beta. That's why I have listed them separately, and that's why aryl halides will never give SN reactions like alkyl halides. I hope eh beta, my board got stuck. Chalo, let me iterate that. Eh? A move. Chalo, my board got stuck. So okay, although my job is also done. So last point is alkyl halides. Aryl halides do not give SN reaction like alkyl halides. They never give. Why? Because of these reasons. But yes, if you introduce electron withdrawing groups, then sir, you are changing. You are again going to electronic factor. Yes. If I increase delta positivity in the carbon attached with halogen, then what will happen? So first, how you can do that? By adding electron withdrawing group at ortho and para position. So if I substitute aryl halides with ortho and para substitutions of electron withdrawing group, then sir, nucleophilic addition can take place. The very famous NCERT reactions. So nahi beta, this has stuck. Chalo. So let me just show you those reactions, because obviously we are intending to finish NCERT, which we have already done for alkyl halides as well. So let me just give you those aryl halide reactions, because they are not important beta. They are super important. They are super important. So these all facts we have already seen. SN1, SN2, these haloarenes, these 4 points which NCERT has taken 2 pages, but yes. So generally, if you introduce this NO2 at para position, technically this aryl halide was very difficult. Just let me decrease the brightness so that you can see, or else it is quite white. Now I guess it is quite readable for everybody. Now just see this. What I said is here. This aryl halide will never undergo SN reaction, but I can make this aryl halide react. How? By supercharging the nucleophile. So this OH minus ion is given a temperature of 623 Kelvin, 300 atm pressure, and now after this, followed by hydrolysis, you will get your phenol. This is your famous Dow's process. We'll be studying this process in the chapter of phenol also. But sir, if you introduce NO2 at para position, see no pressure, temperature also reduced, and same substitution has happened. If I've introduced 2 nitro groups, then sir, temperature from 443, 368, no pressure sir. And if you introduce 3 nitro groups, even you only add warm water and substitution will take place. This is a very beautiful compound called picric acid. Picric acid, which is nothing but 2,4,6 trinitrophenol. I hope everybody is clear. Perfect. Now, with this, definitely we bring the end of alkyl and aryl halides. Yes, there will be some practice questions in my slide. There will be some good practice sessions and some basic informations about polyhalogen compounds. So yes, those 2-3 pages is definitely there for you to read. Although if you want anything from these areas, that's this I want you to repeat, just go to the comment section after the live is complete. Whatever doubts, whatever queries you have, please mention that. And if you are working, then definitely I will also be working more. So the next session that I'll be having, first I'll be dealing with the doubts which you will be placing in the live in the comment section, and then definitely, as promised, what we have said, that we will be discussing the complete class JEE syllabus, not class, JEE syllabus as per NCERT. So we'll be continuing with the session. So this is it. Gaurav Singh Arora at 1 a.m. signing off with the intention and feeling and blessings that you will be doing great with yourself, with whatever you are desiring to do. So best of luck. Good night. Take care, bachcho. Bye-bye. Bye.